Hello everyone and welcome to the Introduction to Python online course in under 6 hours. My name is Walid Al-Hifni and I'll be your instructor for this crash course. Today we are going to learn Python for beginners, so you do not need to have any programming knowledge to understand the content. We will try to cover as much core topics as possible to let you begin your programming journey. Moreover, this crash course is useful if you want to get into programming and are learning Python on your own, or if you are taking it as part of your school or university program. First of all, we need an editor to write our code in. You can either download an offline editor like PyCharm or use an online editor on your browser. In this course, for simplicity, we will use an online editor called Online IDE Pro, and you can find the link in the description. Secondly, let's review the topics that we will discuss in this course. First of all, we will start with inputs and outputs, followed by arithmetic operations, and then comparison operations, followed by conditional statements, and then quick tips regarding strings and numbers, followed by lists, and then quick tips regarding data type conversion, followed by loops, and then quick tips regarding operations on lists, and finally we will end with tuples and dictionaries. And now let's start coding. Let's start with one of the very first or basic concepts in programming, which is displaying an output to the user or printing a value to the user. To do so in Python, we use the print statement. So basically we write print followed by brackets, and inside of the brackets, we write the value that we want to display or print to the user. One of the very first tasks anyone who is learning programming is asked to do is print out the phrase hello world. This phrase, it's a sentence, it's a form of text, and any form of text in programming is called a string. So we want to print the string hello world. To do so, we need to write it inside of the brackets of this print statement. However, we need to tell Python that this value, it's a string, it's a form of text. So we use double quotations, and inside of the double quotations, we write our string, which is hello world. Now, if we click on the run button, as you can see, it printed out hello world. What if we want to print a numerical value, a number? For example, the integer value 5. We can have a new print statement, and inside of the brackets, we can directly write 5 because it's not a string, it's not a text. Therefore, we do not need to use double quotations. We can directly write 5 inside of the brackets and click run, and as you can see, it printed out 5. Now, what if we want to print a combination of a text and a number? For example, we want to print out the number is 5. Here we have a string, which is the number is, and we have a number or an integer value, which is 5. There are multiple ways to do so. For example, we can write print, and inside of the print statement, we can have one big string inside of double quotations saying the number is 5. If we click run, it will actually print the sentence, the number is 5. However, the number 5 is treated as if it is a string or a text, because as you can see, it is inside of the double quotations. Therefore, it is no longer a number or an integer value. It is considered a text or a string. However, if you want to treat it as if it's a numerical value, a number or an integer value, we need to put it outside of the double quotations. To do so, we need to change this print statement. For now, this print statement consists of one value, which is a string, one big string. However, a print statement can have many elements or can contain multiple values. We can write print, and for the first element, it will be our string, which is the number is, and it is inside of double quotations because it's a text, it's a string. And then after the double quotations, we write a comma, which means the first element is done. And now moving on to the second element. And in the second element slot, we can actually write our number, which is 5. So if we click on the run button, as you can see, it printed out the number is 5. And as you can see here, 5 is treated as if it's an integer value, it's a number, because it's outside of the double quotations. As you can see in this print statement, it consists of two elements. The first element is a string, which is the number is, and the second element, it's a number or an integer value, which is 5. And actually, we can modify the string, and after is, we can add a colon for better readability. And if we click on run, it will print the number is colon, then we have our integer value, which is 5. What if we want to add more elements or items to this print statement? If I want to add a third item after the integer value 5, I can simply write another comma followed by the third item that I want to print to the user. For example, we can have a string, and inside of the double quotations, we can say, and the second number is. Now, this print statement has three items: a string, an integer value, and another string. If I want to add a fourth item or element to this print statement, simply I'm going to write another comma after the string, and then I will write, for example, the floating point value 2.75. And here, floating point numbers in programming or in Python are called floats. So here, 5, it's an integer value, while 2.75 is a floating point number, which is a float. Here, this print statement has 4 items. So if I click on the run button, as you can see, it will print all 4 items. It printed the string, the number is, followed by the integer value 5, followed by the other string, which is, and the second number is, and finally it printed out the floating point number or the float value 2.75. And let's add some spaces after the commas for better readability, and we can actually differentiate between the different items present in this print statement. And as you can see, this print statement is a static print statement, which means the values inside of it or the items inside of it are fixed. They do not change. Every time I click on the run button, it will print the same items all over again. So what if we want the user to interact or engage with us? For example, why don't we ask the user to provide us with two numbers as an input, and then we use these two numbers inside of the print statement and print them back to the user? How can we do so while actually all of the items present in this print statement are hard-coded? For example, the number or the integer value 5, I can see it with my own eyes. It's fixed, it's hard-coded. Same, for example, for the value 2.75. I can see it with my own eyes. It's hard-coded and fixed, which means this print statement consists of static items. All of the items inside of it are fixed and cannot change. And the question is, how can we replace these two values, 5 and 2.75, with the two values that the user will give us or provide us as an input? The solution is to actually replace these two values, 5 and 2.75, with two things or two items that change based on the user input. And here comes the concept of variables. So we will replace the hard-coded 5 and the hard-coded 2.75 with two variables. However, first, to differentiate between the two values, let's modify the first string and write the first number is. So here we will have the first string as the first number is, and then the second string will be and the second number is. And if we click on run, as you can see, it printed out the first number is 5 and the second number is 2.75. Here we have the value 5 and the value 2.75. We want to store these values inside a variable, and every time we want to use these values, we use the variables instead of the values direct. So let's say, for example, first underscore number is equal to 5, and then second underscore number is equal to 2.75. Now, I created two variables, like two boxes. The first variable or box is called first underscore number, and it contains the value 5, because now I said that first number equal 5. So I'm assigning the value 5 to this variable or box. And the second variable is called the second underscore number, and it is assigned the value 2.75. So the equal operator assigns values to variables. And I could replace here 5 with first underscore number and 2.75 with second underscore number. Let's click on the run button. As you can see, it printed 5 and 2.75. Although we did not hard code these values, we just used their variables. We have first number and second number, and they contain two different values. I do not know what values do they contain, but I want to print whatever inside this variable or this box, the first underscore number, and this variable or this box, the second underscore number. And actually, we can replace this string, which is the first number is, and also this string, which is and the second number is, with two variables. For example, first underscore sentence equal the first number is, and second underscore sentence equal and the second number is. Now we can replace the first string with its variable, which is first underscore sentence, and here the second string, we can replace it with the second underscore sentence variable. So if we click on the run button, as you can see, it printed out the first number is 5 and the second number is 2.75. Now, this print statement contains for items or for elements. All of them are variables. They could contain anything with any data type. For example, first underscore sentence, it contains a string. However, I could say, for example, first underscore sentence equal 1. And now I replaced this string, the first number is, with the integer value 1. So originally, this variable contained a string. However, now it contains an integer value, which is 1. So if I click on the run button, as you can see, it printed out 1, 5, and the second number is 2.75. Now comes the most important question. We talked about variables, but we did not actually discuss how to take an input from the user. So we said, okay, we're going to take two numbers from the user, we're going to put them inside those variables, and then we print the variables. But we never said how we are going to take these inputs from the user. And to do so, we are going to use the input statement. So as you can see here, first underscore number is assigned the value 5. However, we want to assign it with the value that the user will provide us as an input. We are going to replace 5 with input followed by brackets, and inside the brackets, we are going to write the message or the prompt that will be displayed to the user to inform them that we are expecting an input from them. We want them to provide us with a number. Since it will be a text as string, we will use double quotations and then write enter the first number. And we will do the same for the second underscore number variable because we are also expecting a second input from the user. And we could remove this statement and yeah. So now we are expecting two values to be provided from the user. The first value will be stored in first underscore number variable, and the second value will be stored in the second underscore number variable. And Python runs sequentially. So the very first code will be the very first thing that gets executed. So if I click on the run button, it will ask me, enter the first number. So I will write 2 and then click on the enter button. It will tell me, enter the second number. I will write 3 and click on the enter button. Here it will tell me the first number is 2 and the second number is 3. So the print statement printed the values that I provided because I stored these values in the first underscore number variable and the second underscore number variable. So now let's make things interesting. Instead of asking the user to provide us with two numbers and we just print the numbers, we will ask them to provide us with two words or two strings. And then we will try to combine or concatenate these words and form phrases or sentences. The first thing we need to do is to adjust our variables here. The first underscore number and the second underscore number, we need to change them to first underscore word and second underscore word. And actually, you can name the variables anything you want, even if it is meaningless. However, for readability and documentation purposes, it is preferred to actually name them something meaningful. Now, moving on to the display message or the prompt that will be printed to the user, here instead of saying enter the first number, let's change number to word, and here enter the second number, let's change number to word 2. And moving on to the first underscore sentence and the second underscore sentence variables, we are going to change the strings inside of them. So here we are going to replace number with word, and here we are going to replace number with word. So the first sentence becomes the first word is, and the second sentence becomes and the second word is. Finally, in the print statements, we will introduce the two new variables. Here, instead of first underscore number, it will be first underscore word, and here instead of second underscore number, it is going to be second underscore word. And if we just click on the run button, as you can see, it will ask us enter the first word. Let's enter hello, and then it will ask us enter the second word. Let's enter world. And as you can see, it printed out the first word is hello and the second word is world. However, if I want to actually create a phrase which is hello world combined together, so I want to combine these two words together and create the phrase hello world, I could do something like this. I could create a new variable called phrase equal, and here I will write first underscore word, which is the variable containing the first word, and then I use the plus sign followed by second underscore word, which is the variable that contains the second word. Here, the plus sign will concatenate or combine these two strings together, the string inside the first variable and the string inside of the second variable, and it will create a new phrase. So here, if I change my print statement and I decide to print phrase, and I click on the run button, as you can see, it will also ask me enter the first word. Let's enter hello, and then enter the second word. Let's enter world. And as you can see, it printed out hello world. However, there is no space between the first word and the second word when we combine them or concatenated them together. This is because here, when we said first underscore word plus second underscore word, we took the value inside of the first variable, which is the string hello that consists of 5 characters, and then we combined it or concatenated it with the value inside of the second variable, which is the string world, which also consists of 5 characters. Therefore, it formed a 10-character phrase, which is hello world without a space. Therefore, if I want to have a space, I need to explicitly write it. And here I'm going to write it after the plus sign or the concatenation symbol. So here I'm going to write double quotations because the space is a character in the computer. Therefore, if I want to write a space, I need to write it inside of double quotations as a string because it's a character. So here inside of the double quotations, I'm going to write my space character, and after the double quotations, I'm going to add another plus sign. So here it will concatenate the value inside of the first variable to this string, which is a space, followed by the value inside of the second variable. And if I click on the run button, as you can see, it will ask me to enter the first word. So let's enter hello. And then it will ask me to enter the second word, which will be world. And as you can see, it printed out the phrase hello space world. So the space was actually introduced to this phrase because we wrote it here inside of double quotations. Actually, instead of using the phrase variable, we could put this term directly inside the print statement. So here, instead of print phrase, we will have print first underscore word, followed by the plus symbol. And the plus symbol, when we are dealing with strings, it means concatenation. It will concatenate the strings together. So here we add the double quotations, and inside it we put the space because we want to concatenate a space after the value, which is inside the first underscore word variable, followed by the second underscore word. And we can remove the phrase variable, we no longer need it, and we can also remove these two variables. And let's see what will happen. If we click on run, it will ask us enter the first word. We will say hello. Enter the second word. We will say world. And as you can see, it printed hello world. So you could either use the variables or you can put the term directly inside the print statement, and both will have the same result or the same behavior. Now, Let's roll back to the previous version of this problem. So instead of inputting two words, let's input two numbers as we did before. So we can change the variables into first underscore number. It's optional, you could keep it as it is, but I like to change it. And here second underscore number. And for the prompt message that will be displayed to the user, we will change it into enter the first number and here enter the second number. Now, let's have something interesting. Inside the print statement, I will do this. First underscore number plus second underscore number. Since we will be dealing with integer values, with numbers, do you think the print statement will print the addition or the summation of the two numbers, or will it print something else? Let's wait and see. If we click on the run button, it says enter the first number. We will enter 2 and click on the enter button. Then enter the second number. I will enter 3, but then before clicking on the enter button, will it print 5 or will it print something else? Let's see now. I clicked on the enter button and as you can see, it printed 23. But what is 23? 23 is the concatenation of the character 2 and the character 3 together. This means that our program dealt with the inputs as strings. It did not deal with them as numbers. Because since I used the plus operation, if they were numbers, it will perform an addition. However, it did not perform an addition because we did not specify that the input will be a number. How can we specify that the input will be a number? Here, before actually calling or writing the input statement, we want to tell Python that the first number variable will take an input from the user and we want you to actually store this input as an integer, as a number. So we write int, which is the abbreviation of integer, and then we will have here brackets inside the input statement, as if you are telling Python that whatever value you take from the user as the first input, you need to wrap it as an integer value, as a number. And we will do the same here with the second number. If I click on the run button, it will tell me enter the first number. We will write 2, enter the second number. We will write 3, and when we hit on the enter button, it will print 5. Because here, this plus operation is no longer dealing with two strings or two characters. Now it is dealing with two numbers. And if I'm dealing with two numbers, then this is an arithmetic operation. So the plus means addition or summation. We can actually now have different things to do. For example, let's have a variable called addition, which will be the first underscore number plus the second underscore number. Let's have a variable called subtraction, which will be the first underscore number minus the second underscore number. So now we are getting introduced to the different arithmetic operations we have. Let's have multiplication, which is the first underscore number multiplied by the second underscore number. And as you can see, the multiplication symbol is an asterisk. And then we can have division, which is the first underscore number divided by the second underscore number. And here in the print statement, we want to print these four variables. We can actually say addition, comma, subtraction, comma, multiplication, comma, division. And it will print the four values next to each other. If I click on run, and let's use bigger values. So for example, enter the first number, it will be 10. Enter the second number, it will be 5. And when I click, as you can see, 10 plus 5 is 15. 10 minus 5 is 5. 10 times 5 is 50. And 10 divided by 5 is 2. And as you can see here, the first three numbers are integer values. However, the fourth number is a floating number or a float, because division usually results in floating numbers or decimal points, as we can say. That therefore, the basic or like the default data type of a division operation is a float. And the reason I said that the last value is a float value and not an integer, because it is 2.0. If it was just 2, then it would have been a normal integer. However, since it contains a decimal point or a floating point, therefore it is a float number. Now, let's continue with our arithmetic operations. And after the division comes the floor division, which is a special kind of division, also known as integer division. If we say, for example, integer underscore division, which is the variable name, and then we say first underscore number, and instead of using one forward slash, which is the division symbol, we use two forward slashes, which is the integer division symbol or the floor division symbol, followed by second underscore number. Here, it will perform a normal division operation, but the result will only contain the integer part of this output. For example, if I have 5 divided by 2 in a normal division, it will be 2.5. However, in an integer division, it will be 2 because it extracted the integer part of the result. So if the result is 2.5, it will only output 2 and it will remove everything after the decimal point. Let's try it out in the print statement. We will add here integer underscore division. And let's use the example that I just used. So the first number will be 5 and the second number will be 2. So as you can see, 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, 5 divided by 2 in a normal division is 2.5. However, in an integer division or a floor division, it is 2. And as you can see, it is 2 and not 2.0 because here it removed the decimal point and everything after the decimal point, as if it only extracted the integer part of the division result and displayed it to the user. And this type or the type of this value is an integer. Now, let's move on to another arithmetic operation, which is the exponentiation or the power. So, for example, if I say 5 to the power of 2, we can write it as follows. We can create a variable called power, and then we say the first underscore number, and here we use two asterisks or two stars. Remember, one asterisk or one star refers to the multiplication operation. However, two asterisks refers to the power operation. So the first underscore number to the power of the second underscore number. And if you are not familiar with the power operator, if I say 5 to the power of 2, it means 5 times 5. If I say 5 to the power of 3, it means 5 times 5 times 5. So let's try it out. Here we will add power and we will use the same values. 5 to the power of 2 is 5 times 5, which is 25. So enter the first number, it is 5. Enter the second number, it is 2. And as you can see, 5 to the power of 2 is 25, which is 5 times 5. And now let's move on to one of the most challenging arithmetic operations, which is the remainder operation or the modulus operator. Basically, the remainder is what's left over after you divide one number by another. And to write it in Python, we can create a remainder variable or a variable named remainder, then first underscore number, followed by a percentage sign. And here the percentage sign represents the modulus operator. So the modulus operator is written as a percentage sign, then second underscore number. So here we have a variable named remainder, and it will contain the remainder value of dividing the first number by the second number. Let's have a real life example to understand how the remainder works. Let's assume we have 5 apples and 2 persons, person A and person B. And here we want to actually divide the 5 apples equally among both persons and know how many apples will remain after we divide them equally among them. we can do it in a series of rounds. So let's start with round 1. In round 1, person A will take 1 apple and person B will take 1 apple. Therefore, a total of 2 apples were given. So the remaining apples will be 5 minus 2, which is 3 apples. Because if person A takes an apple and person B takes another apple, therefore a total of 2 apples were given. 5 minus 2 is 3. So we have 3 apples remaining. Can we divide these 3 apples among the 2 persons equally? Yes, we can have a second round where actually person A will take 1 apple and person B will take also 1 apple. Therefore, a total of 2 apples were given. The remaining number of apples this time is 3 minus 2, which is 1 apple. Because if each person takes an apple, therefore a total of 2 apples were given. 3 minus 2 is 1. We have 1 apple remaining. Can we divide this 1 apple among the 2 persons equally? Of course not. Therefore, the final remainder is equal to 1 apple. If I want to divide 5 apples among 2 persons equally, each person will take 2 apples. That's a total of 4 apples. 5 minus 4 is 1. So we are left with 1 apple. Let's actually print the remainder variable and add it here into the print statement. Let's click on run. Enter the first number, 5 apples. Enter the second number, 2 persons. As you can see, the remainder is 1. So we have 1 apple remaining. If you want to know the math behind it, we can actually calculate what the modulus operator does. With the same example, we have 5 apples and 2 persons. The first step, or step 1, which actually happens behind the scenes of this percentage sign or modulus operator, that it divides the 5 by 2, but this time using an integer division. If you recall, integer division actually takes the integer part of the division result and throws away everything after the decimal point. So 5 divided by 2 is 2.5. However, 5 integer division or floor division by 2 is actually 2. Therefore, step 2, we will multiply this 2, which is the result of step 1. We multiply it by the number of persons, which is here 2 times 2 equal 4. So the result of step 1 is 2. The number of persons is 2. So we multiply 2 by 2 is 4. So step 1 tells me how many apples each person will take. So actually here, each person will take 2 apples. Step 2 tells me how many apples are given. So if each person takes 2 and we have 2 persons, 2 times 2 equal 4 apples given. So step 3, which is to calculate the remaining number of apples, we take the result of step 2. Okay, however, we subtract the number of apples minus the result of step 2, which is we have 5 apples minus 4 apples given. That's 1 apple remaining. So the remainder is equal to 1. Because here in step 3, we have the total number of apples 5. We actually gave a total of 4 apples, where each person took 2 apples. So 5 minus 4 is 1. We have 1 remaining apple. These 3 steps are performed by this symbol, which is the modulus operator. So now let's beautify our output. Instead of printing all of the variables on the same line, let's print each variable on a separate line. And we can, for instance, add some sort of strings or texts being printed to the user to explain the value. For example, 7 is the addition of the first and the second number. 3 is a subtraction of the first and the second number. So let's print each variable on a separate line with some sort of a string explaining this value. The question is, can we have multiple print statements in our code? The answer is yes. We can delete this example and we can remove this print statement. And let's create a new print statement saying, for example, the addition is followed by comma and then the variable name. So here we will print the string or the text the addition is, therefore it is in double quotations because it is a string, followed by the variable name. So it will print the value inside this variable. We can do it also for subtraction. The subtraction is, comma, followed by the variable name. And if we click here on run, it will say enter the first number 5, enter the second number 2, and as you can see, the addition is 7 and the subtraction is 3. And each is on a separate or a different line. Another concept we can introduce is the comments. So for example, for you as a programmer, you may create a new functionality or you may have many variables inside your program and you may forget what values are in these variables. You need some sort of like comments to remind you about, for example, the functionality of the code you've written or the values inside a particular variable. In programming, comments help you to write a neat and a documented code. In Python, to write a comment, we use the hash symbol, and anything after the hash symbol, as if Python does not see it. It will not get executed. It's not a form of code. It's just for you as a programmer to understand or to remember what does the program do or what values do the variables contain. Let's have an example. Here, for example, at the addition variable, I could use a hash symbol and say adding the first and second numbers. And as you can see, it is written in a different color because this is for you as a programmer. Python will not execute whatever after the hash symbol. This is for you to remember what does the value inside the addition variable mean. It's adding the first and the second numbers. The power, we can have here a command saying this is the first number to the power of the second number. Because, for example, you may not know the double asterisk or you may forget the functionality of the double asterisk. Also, you could create here a comment saying the print statements or printing the variables to the user. You could have it on a separate line. It's just for you as a programmer. Here, for example, we can have taking input from the user. It's a command for you to understand that this next piece of code, you are taking input from the user. Here, we can say performing arithmetic operations on the input values from the user. We can remove this comment. We can also remove this comment, for example. And when we execute it, we click on run, nothing will change. First number is 5, second number is 2, and we here have the two print statements. So the comments did not affect my code. As I said, it's for you for a better documentation, because if you're working in a team with multiple programmers, each programmer works on a specific functionality, you need to document, you need to write commands for the other programmers to understand the functionality if they want to review your code, or actually if they see your code and don't understand what did you do. However, for example, if I write anything without the hash, so here, for example, the end of my code, and I click on run, an error will appear telling me invalid syntax error, because to Python, this is not inside a hash. This is just the end of my code. It may be variables, it may be an operation. Python is not aware of it, so it will throw an error saying this is invalid syntax. I do not understand what did you write. However, if I just use here a hash symbol and click on the run button, my code will work normally. So don't forget, if you want to write comments or to write stuff that is not coding or not programming, you need to put it after a hash symbol in Python. Also, there is another use of comments. What if I want to only execute the first print statement, which is the addition result? I don't want to print the subtraction result. One could say, let's remove or delete this line of code. However, this is not efficient because you may need this line of code in the future. So you will not just delete it and rewrite it again. It's not an efficient technique. The answer or the solution could be we can just comment this line of code by writing a hash symbol before the print statement. Here, Python can no longer see the second print statement. If I click on the run button and input the two numbers, it will only execute the first print statement, which is the addition, and it will not execute the second print statement because it is commented, as if Python cannot see it. So it will not execute it. What if I want the opposite? I want to actually comment the first print statement and I only want to output the subtraction result. Here, if I enter the two numbers, it will only print the subtraction result. What if I just comment both print statements? Here, of course, nothing will be printed, as you can see. So the comment symbol is actually useful not only for writing notes for you as a programmer, but also for actually hiding some parts of the code from Python which you may need to execute later on or use later on, as you've seen here with the two print statements. Now, let's move to something interesting. If you remember at the beginning of the tutorial, we printed everything using one print statement. Here, let's comment the second print statement because maybe we will need it in the future. And let's here add the content of the second print statement to the first print statement by adding a comma followed by and the subtraction is followed by another comma and then the variable name, which is subtraction. So here I'm printing the addition and subtraction values on the same line. If I click on run and I enter the two values, as you can see, the addition is 7 and the subtraction is 3. Since this print statement contains 4 elements, we have 2 strings and we have 2 variables separated by commas. So I have the first string, comma, the variable, comma, the second string, and then comma, the fourth variable. However, this is also not an efficient technique, and there is a modern way to write everything in the same print statement instead of using commas. Let's see how can we do it. Let's remove this comment and let's create a new print statement. We wrote print as we did before. However, here is the new technique. Here we will write the letter or the character F followed by double quotations. So here I have F followed by double quotations. And inside the double quotations, I will write the string that I wrote in the previous print statement, which is the addition is. However, instead of writing comma followed by the addition variable, I will actually add a space, then I will add curly brackets. As you can see, those are curly brackets. And inside the curly brackets, I will write the variable name, which is addition, followed by another space, and the subtraction is, followed by curly brackets, and inside it we have the variable name. So here we did not use commas. Here we have one big string containing the two previous strings, the addition is and the subtraction is, and also it contains the variable names. However, for Python to understand that you want the value inside this addition and this subtraction variables not to print the word addition and the word subtraction, you put them inside curly brackets. If I comment the first print statement and I run this code, enter the first number is 5, enter the second number is 2, and as you can see, it printed the addition is 7 and the subtraction is 3. If I did not use curly brackets, and I just wrote here addition and subtraction, and I commented this one, and I click on run, enter the first number 5, enter second number 2, as you can see, it printed the addition is addition and subtraction is subtraction, because Python no longer knows whether this addition, it's a string, it's a variable, and since it is inside double quotations, it's automatically by default a string. So to Python, it's no longer a variable, it is a string. So if you want Python to understand that this is a variable name, you put it inside these curly brackets. And don't forget that before the double quotations, we use or we write the letter or the character F, which tells Python, take care, this string will contain a mix of text and variables, and the variables are surrounded by curly brackets. So if we click on run, we'll enter the first number and the second number, and here we have 7 and 3 printed inside the string. And actually, here it will replace the variable name with the value inside it regardless of its type, whether it is an integer, it's a floating point number, or even a string. It will just print or display the value inside the variable regardless of its type. So let's have an example. Instead of inputting the second number as an integer, let's input a floating point number or a float. However, we will face a problem here. If we just click on run and we enter, for example, 5 as the first number, however, as the second number, we want to enter 2.5, which is a float. If we click on enter, we will receive an error because here, as you can see, the second number, we wrap the input as an integer, as an int. However, we input a floating point or a float number. So we need to change this int and we write float. So Python knows that the second number will be a float. And if we click here on run, we enter 5 as the first number, we enter 2.5 as the second number, and as you can see, the addition is 7.5 and the subtraction is 2.5. So it actually performed the addition and the subtraction, and it replaced the variable names with the values which have the type float. Now, what if we want the user to input a string or a text as the second input? We can simply comment this line of code because we may use it later, and then we create a new variable called second underscore input equal input, and then we provide it with the message, enter the second input. If we leave it like this, Python will treat it as a string. However, we can force Python to treat it as a string by wrapping it around str, which stands for string. So if we put the input statement inside of an str, here Python knows that the second input provided by the user is of type string. It is text. Now we have the first input as a number, as an integer number, and the second input as a string or a text. However, we cannot perform arithmetic operations on an integer and a string. So we can just simply print the values that the user will provide us. So we can comment this print statement. We can create a new print statement. And inside the brackets, we write F followed by double quotations. And inside the double quotations, we say the first input is, then we have curly brackets inside it, the variable name, which is first number. And then after it, to continue with our string. And the second input is another curly brackets with the second variable name. Here, it will print the values that the user will provide us. However, since Python runs sequentially, So this part of code will get executed before the print statement. And this part of code will cause an error because it is using the second number, which is already commented. So to Python, what is the value inside the second underscore number variable? It does not exist. So it will throw an error. One solution is to delete it or to comment this piece of code. One way to do it, we can put a hash symbol before every line. However, it is time consuming to do it, especially if you have many lines of code. So there is a shortcut. If you remember this forward slash symbol, we can actually use its button on the keyboard to comment an entire piece of code. We can do so by highlighting the piece of code, as you can see, then clicking on Control on Windows or Command on Mac, followed by the forward slash button. Control or Command plus the forward slash button on the keyboard, it will actually comment this entire piece of code. If we click on Run, enter the first number, we enter 5, enter the second input, which is of type string. So let's type hello world. And if we click enter, it will print the first input is 5 and the second input is hello world, as you can see. And now let's move on to a different kind of operations, which are the comparison operations. But first, let's clean our code and remove everything we will no longer use or need in this upcoming section. For example, these print statements are no longer needed, so we are going to delete them. Also, these arithmetic operations are no longer needed. But before removing them, let me show you a quick hack. Remember, when we wanted to comment this piece of code, we highlighted it and then we used the shortcut Control on Windows or Command on Mac, followed by the forward slash key. If we want to uncomment it, we can use the same exact shortcut, Control or Command, followed by the forward slash key, as you can see. So if I use it one more time, it will comment it. If we use it another time, it will uncomment it. However, we no longer need this entire section, so we are going to just delete it. Also, for the comparison operations, we are going to compare two different numbers. So we don't want the second input to be a string, so we are going to remove the second underscore input variable. However, we need the second underscore number variable. So we are going to uncomment it either by removing the hash symbol or by using the shortcut, or we highlight it and then we use the shortcut. So the user will provide us with two numbers, and for simplicity, let's assume both numbers are integers. So the user will provide us with two integer values, and we will perform different comparison operations. And now let's discuss the different comparison operators we have. And let's start with the greater than operator, which has this symbol. If we create a variable called greater underscore than, and here we want to compare whether the first input by the user is greater than the second input or not. We will write first underscore number greater than second underscore number. Here we are comparing the value inside the first underscore number variable, whether it is greater than the value inside the second underscore number variable or not. And the outcome of this operation will either be true or false. True meaning the first value is greater than the second value, or false, which means the first value is not greater than the second value. We expect the outcome to be true or false. This variable, which is called greater underscore than, will store either the word true or the word false. However, these words are very special in programming. They are called booleans. So we have a data type called the boolean data type, which can have only two values, true and false. This variable, which is called greater underscore than, will have the type boolean because this operation is a comparison operation, and comparison operations result in a boolean outcome, true or false. And by the way, it is case sensitive. So true with an uppercase T and false with an uppercase F. Let's have an example, but before writing an example, let's print the variable greater underscore than, and let's click on the run button. Our example will be enter the first number 5 and enter the second number 2. Before hitting the enter button, 5 is greater than 2, so we expect that Python will print true. If we click on the enter button, it prints true because 5 is greater than 2. Another comparison operator is the greater than or equal, which is like this. If we create a variable called greater than or equal, and we want to actually check whether the first value is greater than or equal the second value or not, and here we want to print the variable, but this time let's have some sort of meaningful strings. We can write f followed by double quotations, and we say greater than or equal. We then have the curly brackets, and inside it we write the variable name. We can do so for the first print statement, but here it is just greater than, and here it is just greater underscore than. So here we are going to print greater than and the result, and here we are going to print greater than or equal followed by the result. If we click on the run button, enter the first number 5 and enter the second number 2, and as you can see, greater than is true and greater than or equal is also true because 5 is greater than or equal to 2. If we do something like this, run, enter the first number 5, and here we enter 5 as the second number. As you can see, greater than is false because 5 is not greater than 5. It is equal to 5. However, greater than or equal, it is true because 5 is greater than or equal to 5. It is equal to 5, which is included in this comparison operator. Therefore, it is true. Now, let's continue with the other operators. For example, we have the less than operator, which is like this. So we can create a variable called less underscore than equal. Let's check whether the first underscore number is less than the second underscore number. And we are going to actually print it, but let's copy the print statement. And here, instead of greater than, we say less than, and here, less underscore than. We also have the less than or equal, which is like this. So we can create a variable less underscore than underscore or underscore equal whether the first number is less than or equal to the second underscore number. And we are going to print it less than or equal, and here less underscore than underscore or underscore equal. Finally, the last two operations, the equal to operation, which we compare whether the two numbers are equal or not. So we can create equal underscore to equal whether the first underscore number is equal to the second underscore number. And as you can see, the equal symbol here is two equal signs, because as you can see, one equal sign, I'm assigning a value to a variable. However, two equal signs means I'm comparing two values together. Therefore, the equal to symbol is two equal signs. And we can print it. Print here, we say equal to equal underscore to, and finally not equal to, meaning the first number is not equal to the second number, and the symbol is an exclamation mark followed by an equal sign. We can say not equal to equal the first number is not equal to the second underscore number. And we also have our print statement, print not equal to, and the variable name is not equal to. As you can see, we have these different comparison operators: greater than or equal, less than or equal or not equal. And let's have a small example. If we click on run, enter the first number, 5, and enter the second number, 2. As you can see, 5 is greater than 2, which is true. 5 is greater than or equal to 2, which is true. 5 is less than 2, it's false. 5 is less than or equal to 2, which is also false. 5 is equal to 2, not true, it is false. And is 5 not equal to 2? Yes, 5 is not equal to 2, therefore it is true. And if you remember, I told you that all of these 6 variables, they contain a Boolean value, either true or false. However, in Python, there is a way to determine the data type of any variable you have in the code. For example, if we want to know the data type of the first underscore number variable, we can create a new variable called type underscore first underscore number equal, and then we write the word type followed by brackets, and inside the brackets we write the variable name first underscore number. So here we want to know the type of the variable first underscore number. What if we want to know the type of the variable greater underscore than? We create another variable, type underscore greater underscore than equal, we write type, and then inside the brackets, we write the variable that we want to know its type. Here it is greater underscore than. Then we can print these two variables. We can use the old print technique. For example, print the first underscore number data type is, comma, and then here we write type underscore first underscore number, and we can do it also for the greater than type. The greater than data type is, comma, and then type underscore greater underscore than, and let's comment the rest of the code, but let's keep the greater than because we are going to use it. Here we are going to use the shortcut, and then if we click on run, enter the first number, it is 5, enter the second number, it is 2, and as you can see, the first number data type is int, which is integer, and the greater than data type is bool, which is the abbreviation of Boolean. So here, Python told me that the first underscore number stores an integer value, while the greater underscore than variable stores a Boolean value. What if we change the second underscore number variable into a float instead of an integer, and we decide to actually get its data type too? So type underscore second underscore number, we create a new variable, we write type, and inside the brackets, we write our variable name, which is second underscore number, and here let's print it. So the second number data type is, and then we replace the type underscore first underscore number with the type underscore second underscore number. Let's print it. We click on run, enter the first number is 2, enter the second number. Here it's a float. We need to write a floating point number, which is 1.5, for example. We click on enter. As you can see, the first number data type, it's int. The second number data type is float. So Python knew that the second underscore number variable stores a floating point value. And definitely the greater than variable is of type bool or boolean. And as you can see, we can perform comparison operations between integers and floating point numbers because at the end of the day, both are numbers. Let's have something like this. Third underscore input, a new variable, equal string input, enter a text. Like this. And we want to know the data type of this variable, which is called third underscore input, which we know that it's a string because we use the str and we request the user to provide us with a text. Here we write type underscore third underscore input equal type, and we want to know the type of the third underscore input. Let's just copy this and paste it, and the third underscore input or the third input data type is type underscore third underscore input. So here, if we click on run, enter the first number, it's 5, enter the second number, and don't forget, here it's a floating point. So let's write 1.5, enter a text, hello world, and then if we click on enter, as you can see, the third input data type is str, which is string. What if we remove this? So we removed the str wrapping and we clicked on run, enter the first number 5, enter the second number 1.5, enter a text, the same exact text, hello world. We click on enter, and as you can see, the default data type of the input statement is string, str. Here we did not say that it's a string. However, since the default type is string, it told me that its data type is string. And now let's move back to the comparison operators and ask ourselves, why are the comparison operators important and how can we use them in our code in a meaningful way? The answer is simple. If we want to create a condition and based on this condition, if it is true, we want to execute a specific piece of code or perform a specific action. Otherwise, if the condition is false, we want to execute a totally different piece of code or perform a totally different action. Here, we can use the comparison operators to create these conditions, which introduces us to the conditional statements in programming, where the conditional statements use the comparison operators to create multiple conditions. Let's have an example. We are going to delete everything and keep the first variable, and we are going to rename it to grade and ask the user to input their grade. Enter your grade. And we will write a simple conditional program where if the grade is greater than or equal to 50, we are going to print you passed, something like this, you passed. Otherwise, if the grade is less than 50, we are going to print you failed, for example, something like this. Here, we want to create a condition. How can we create a condition and based on this condition, we only print one of these two statements? We don't want to print them both. We want to print one of them based on a condition. If the grade is greater than or equal to 50, we are going to print you passed. Otherwise, we are going to print you failed. Here, we introduce the if conditional statement. Basically, we write if followed by the condition we want, which is grade greater than or equal to 50. We can actually leave it like this, or we can put it between brackets. Both will work. However, let's leave it without brackets. And then after we finish our condition, we write colon, which means now the if statement is done. The condition is done. And the next couple of lines, we want to have the then statement, which means what will happen if the condition is true. We call it the if then else statement, because if you have the condition, then you have the body if the condition is true, else you have the body if the condition is false. So to actually indicate that we are in the then statement, we write the colon, and then Python works with indentations, where an indentation is used to define blocks of code. Basically, it tells Python that a group of statements belong to a specific block of code. Here, the print statement of you passed belongs to the then part of this if statement. If the condition is true, we want to execute this print statement. So here, we actually put our cursor before print and we hit the tab button on our keyboard. As you can see, this space is the indentation, which tells Python that this print statement belongs to this if condition. Okay, it's part of this block of code. And actually, this is the statement that will get executed if the condition is true. Otherwise, we want to print you failed. And here comes the else part of the if statement. We write else followed by colon, which means, well, if the condition is false, Python will move and will actually execute the body of the else statement. So we write else followed by a colon to indicate the body of the else statement. And here we put our cursor before the print statement and hit the tab key. So as you can see, we have our if statement. The condition grade is greater than or equal to 50. If it is true, we are going to print you passed. Then we have the else condition. If it is false, we are going to print you failed. Let's try it and click on run. Enter your grade. If we enter 60, we expect Python to print you passed. As you can see, it printed you passed. Otherwise, if we click on run and we enter 30, it printed you failed. What if we did not have an else part? If we just comment the else part and we only had an if part, nothing will occur if we enter a grade lower than 50. If we enter 30, nothing was printed. Here, we did not specify an else part. There is no body, there is no else, so nothing will get executed. However, if we kept our else part, enter our grade 20, it will print you failed. Now, let's make things even harder. What if we have a grading scheme like this? For example, let's write some comments. If the grade is between 90 and 100, then it is an excellent grade. If it is between 80 and 89, then it is a very good grade. If it is between 70 and 79, then it is a good grade. If it is between 60 and 69, then it is satisfactory. If it is between 50 and 59, then it is pass. If it is less than 50, then it is a fail. And we want to print whether the user scored an excellent grade, a very good grade, etc. How can we do so? This introduces us to the concept of having multiple conditions. And if the first condition fails, we move on and check on the second condition. If the second condition fails, we move on and check on the third condition, and so on. So how can we do this in Python? Let's have an example. Let's delete this and start from scratch. At the very beginning, we will check whether the grade, let's use brackets this time, if the grade is greater than or equal to 90, followed by a colon. So here we are going to check on the first condition. If the grade is greater than or equal to 90, then we will have the print statement that prints excellent as the body of this if statement. If I click on enter after the colon, it will automatically create the indentation. So if I write print excellent, as you can see, there is a space here because it automatically did the indentation for me. However, if you clicked on enter and for any reason it did not do the indentation, you need to actually click on the tab button to move it one space to the right. Because here the indentation refers to that this print statement is part of the body of this if statement. If the condition is true, you will execute this print statement. Now, what if the condition is false? The grade is not greater than or equal to 90. We are going to check on the second condition, whether the grade is between 80 and 89. Here, if I click on enter, as you can see, the cursor is on the same indentation level as the print statement. If I, for example, wrote another print statement, print hello, it is on the same indentation level, which means that if the condition is true, it will print both statements because you can have multiple statements inside an if condition in the then part. If the condition is true, you can perform multiple actions, not only one. However, we here are interested only in one statement, which is the print excellent. So we don't want this print statement, the second one, or we don't want to be on the same indentation level as the print statement. So if we click enter and we find the cursor on the same indentation level as the print statement, we click on the backspace key, which actually puts us at the beginning of the line. Here, we want to write the second condition. We will introduce the concept of elif, which is L-if, stands for else if. Else, if the first condition is false, check on this new if condition, which is grade greater than or equal to 80. Here we are going to print very good. So if the first condition is false, elif, which stands for else if, check whether the grade is greater than or equal to 80. If it is actually greater than or equal to 80, we are going to print very good. Otherwise, we want to create another condition. So we have another elif condition, grade greater than or equal to 70. And here we are going to print good. Otherwise, if the grade is not greater than or equal to 70, we will have another elif condition, which is the grade greater than or equal to 60. Here we are going to print satisfactory. Otherwise, we will have another elif, or as we call it, else if condition. If the grade is greater than or equal to 50, we are going to print pass. Otherwise, we can either write elif grade is less than 50, or as we've seen in the previous example, we can simply write else because we no longer have any other conditions. If the grade is not between 50 and 59, any other grade, it will result in a failure. Anything below 50 is a failure. So else here, and we print fail. As you can see, here we have our main if statement, checking on the first condition. If it's true, we are going to print excellent. Otherwise, if it is not true, we are going to move to the second if condition in this elif statement, and we are going to check on a totally different condition. If it is true, we are going to print very good. Otherwise, we are going to move on to the next elif condition or else if condition and check on the condition and so on. So let's trace with an example. If we click on run and we enter 95, we expect the output to be excellent. If we click on enter, Python printed excellent. What if we print or we input 81? We expect it to be very good, which actually happened, and Python printed very good because Python checked the first condition. Is 81 greater than or equal to 90? No. So we move to the second condition. Is 81 greater than or equal to 80? Yes, it's true. Therefore, we are going to print very good and then end this piece or block of code. Let's try, for example, 70. Here 70 printed good because the range of good is 70 to 79 inclusive. So here is the grade greater than or equal to 90? No. Is the grade greater than or equal to 80? No. Is the grade greater than or equal to 70? Yes. True. Therefore, I'm going to print good. Let's try, for example, to input 64. Here it is satisfactory. Let's also try, for example, 59. It is pass. Let's try 49 this time, which is fail, because this is the else statement. If no condition is true from the previous conditions, anything will fall to this else statement and it will execute its body. So if I run it, for example, on 20, it will also print fail. And now let me show you a quick hack regarding the if conditional statements. If you recall the very first example we had on conditionals, where the user provided us with their grade and we then printed whether they passed or they failed, let's first comment this piece of code and then let's recreate the old example. If grade is greater than or equal to 50, we print you passed. Otherwise, in the else part, we are going to print you failed. What if I tell you that I can write these 4 lines of code, this block of code, this if conditional block, in a single line? Let me show you how can we do it. I can create a variable called result equal, and then I assign it to the string you passed. However, I will assign it to the string you passed based on a particular condition, which is if the grade is greater than or equal to 50. Else, I will assign it to the string you failed. So this variable, which is called result, can either have one of two values, one of two strings. It can be assigned the string you passed if the grade is greater than or equal to 50, or it will be assigned the string you failed if the grade is not greater than or equal to 50. Let's try it out. Let's have here a print statement and print the variable directly. And here let's comment this part of the code. If we click on run, enter your grade. If we enter 60, it printed you passed, because here the value of this variable depends on this condition. Here it will contain you passed if the condition is true. Otherwise, if the condition is false, it will contain the string you failed. And we call this sometimes the conditional expression, because it's an if condition in a single line, and the result is actually stored in a variable. And we can use the variable later on. So let's have another example, but this time with a grade less than 50. If we click on run, enter your grade, let's enter 20 for example, and as you can see, it printed out you failed, because 20 is not greater than or equal to 50. Therefore, this if condition evaluated to false. And when it is false, it moves to the else part, which assigns the string you failed to the variable result. Now we are done with this hack. Let's have a totally new example. Let's delete everything. And let's assume the user will input two values. The first value will be their midterm exam grade, and the second value will be their final exam grade. Let's rename the first variable and call it midterm underscore grade. And let's change the message, enter your midterm exam grade. And let's create a second variable called final underscore grade, which will be an integer input where we will ask the user to enter your final exam grade. Here we can have many scenarios. One scenario, let's write the scenarios using comments. But first, let's say that maximum or total grade is equal to 100 here, and here the total grade is equal to 100. So a student or a user can score a maximum of 100 in the midterm exam and a maximum of 100 in the final exam. So for the overall course grade, it will be out of 200, the 100 plus the other 100. We can have actually many scenarios or multiple scenarios. One scenario is for a student to pass the course. We can create one of the scenarios to be, number one, the student must score a total of 100 or more in the course. So here, we do not care about the midterm grade or the final grade individually, we care about the total. So the total grade should be 100 out of 200, greater than or equal to 100, so the user can actually, or the student can pass the course. We can create a variable called total, and then we say midterm underscore grade plus final underscore grade, and we create a simple if condition. If total is greater than or equal to 100, we print you passed, or let's print pass for simplicity, else we print fail. So here it's a very basic scenario. If we click on run, enter your midterm exam grade, 60 out of 100, enter your final exam grade, maybe 77 out of 100. And as you can see, Python printed pass because 60 plus 77 is greater than 100. therefore the student passed the course. So this scenario was based on the total grade achieved. So we added the midterm grade and the final grade, and if the total grade is greater than or equal to 100, then we are safe to say that the student passed the course. Let's have another example. If we click on run, enter your midterm exam grade, let's enter 10, and for the final exam grade, let's enter 70. As you can see, it printed out fail because 10 plus 70 is 80, and 80 is not greater than or equal to 100, which is the threshold to pass the overall course. So even if you passed your final exam, but still the overall grade did not qualify you to pass the overall course. The midterm exam is out of 100, the final exam is out of 100, therefore the total course grade is equal to 200, which is the midterm plus the final exam grades. So here, since the student achieved less than 100, they failed the course. This is a naive approach to actually calculate whether a student passed or failed the course. We just added the midterm grade and the final grade, and we assume that the half of the total course grade, which in this case is 100, will be our threshold, and to pass the course, you need to score a grade of 100 or more. However, we can have a second scenario for a student to pass the course. Here, let's say first scenario, and it only had one condition, which is the student must score a total of 100 or more in the course. However, the second scenario will have two conditions. Let's say the student must score a grade greater than or equal to 50 in the final exam, and we will have a second condition where the student must score a grade, but this time greater than or equal to 30 in the midterm exam. So here we have two conditions. To pass the overall course, you need to score more than 50 or greater than or equal to 50, and this is in the final exam, and to score a grade greater than or equal to 30 in the midterm exam. How can we do so in Python? We can create an if condition and say if the final underscore grade is greater than or equal to 50, which is the first condition in the second scenario, and then we use the AND operator. We write AND. The midterm underscore grade is greater than or equal to 30, followed by a colon. Here we can print pass, otherwise we will print in the else body fail. So as you can see, here we have a big condition consisting of two elements, and both elements must be satisfied. They must be true for the overall if condition to be true. Why did we say so? Because we used and here and indicates that the first condition and the second condition must be true for the overall condition to be true. The final grade must be greater than or equal to 50, and the midterm grade must be greater than or equal to 30. As you can see, I say and. So both conditions must be satisfied for the overall if statement to be true, and it prints pass. Let's comment this part. Let's click on run. Here, let's enter a midterm grade of 60 and a final grade of 77. Here it printed out pass because 60 is actually greater than or equal to 30. This is the midterm grade. So 60 is greater than or equal to 30. And here the final exam grade 77 is greater than or equal to 50. What if I click on run? Here I enter 10 as the midterm exam grade. However, I enter 70 as the final exam grade. As you can see, it printed out fail. Although the final exam grade, it is 70, which is greater than 50. However, the midterm exam grade is 10, which is not greater than or equal to 30. Therefore, if the first part of the condition is true and the second part is false, and we are using and, the whole condition will be false and it will go to the else part. Let's do it the other way around. If we click on run, and this time the midterm exam grade will be 70, but the final exam grade will be 10, as you can see it printed out fail. Because although 70, which is the midterm exam grade, is greater than or equal to 30, so the second condition is true. However, the first condition, the final exam grade, which is 10, is not greater than or equal to 50. Since the first condition is false and the second condition is true, and we are using an and, false ANDed with true will result in a false. The overall condition will be false, therefore I will go to the else part and print fail. And as you can guess, if we input 10 as our midterm grade and 20 as our final exam grade, it will print fail because both conditions are not satisfied. The midterm exam grade, which is 10, 10 is not greater than or equal to 30. It is less than 30. Therefore, the second condition is false. And here the final exam grade, which is 20, it is not greater than or equal to 50. It is less than 50. Therefore, the first condition is false, and thus the overall condition is false, and it goes to the else part and prints fail. Now, let's move on to a totally different third scenario. What if for a student to pass the overall course, they only need to pass one of the two exams? Either they pass the midterm exam or they pass the final exam. They do not need to pass both exams in this scenario. We can write it as follows. The student must pass one of the two exams, which means they score a grade greater than or equal to 50. So if you score a grade greater than or equal to 50 in one of the two exams, whether the midterm exam or the final exam, you will pass the overall course. How can we implement it? We can write an if statement, and starting with the first condition, you can pass the course by only passing the final exam, which means that the final grade must be greater than or equal to 50. Now, if I want to add the second condition, here I will use the OR operator, or I will write OR, which means either the first condition should be true or the second condition should be true for the overall if statement to be true. And in this case, it will be midterm underscore grade greater than or equal to 50. If one of both conditions is true, I'm going to print pass. Otherwise, I'm going to print fail. So let's try it out, but before that, we need to comment the second scenario, and let's have a very basic scenario, or a very basic example. Enter your midterm exam grade, it will be 60, and for the final exam, we'll input 70, and as you can see, it printed out pass, because here in the third scenario, we need at least one of the two conditions to be true for the overall condition to be true. And here, as we can see, we are lucky because both conditions were true. So the midterm exam grade, which is 60, it is actually greater than or equal to 50. So the second condition is true. And also the final exam grade, which is 70, it is greater than or equal to 50, which means the first condition is true. And here we only care about one of them. So if the first condition is true or the second condition is true, at least one of them is true, then the overall condition will be true and will print pass. If we try it with a different example, the midterm exam grade this time is 10. However, the final exam grade is 70. Here it printed out pass because although the midterm exam grade it is 10, which is not greater than or equal to 50, so the second condition is false. However, the first condition is true because the final exam grade, which is 70, it is greater than or equal to 50. And since the first condition is true and we are using here the OR operator, therefore it's either this or this. One of them is sufficient for the overall condition to be true. And since the first condition is true, the second condition is false, then the overall condition will be true since we have at least one true condition, and here it will print pass. What if we try it the other way around? Here it is 70 as the midterm exam grade, but 20 as the final exam grade. Here it printed out also pass, because even if the final exam grade is 20, which is not greater than or equal to 50, so the first condition here is false. However, the second condition, the midterm exam grade, which is 70, it is greater than or equal to 50. So the second condition is true and the first condition is false. However, since at least one of them is true, then the overall statement will be true. The only case in an OR statement where the overall condition will be false if both conditions are false, like this. If we click on run, the midterm exam grade is 10 and the final exam grade is 20. Here it printed out fail because both conditions were false. 10 as the midterm exam grade is less than 50 and 20 as the final exam grade is less than 50. So it means the first condition and the second condition both are false. Therefore, the overall condition will be false and it will print out fail. Let's uncomment the second scenario so we can compare the AND and the OR operators. Here in the second scenario, where we used the AND operator, for the overall if condition to be true, all of the conditions inside the if must be true if we are using AND. So if we are using AND, all of the conditions inside the if must be true for the overall if condition to be true and to print pass. However, here, when we use the OR operator, for the overall condition to be true in the OR operator, or when we use the OR operator, at least one of the conditions inside the if statement must be true. So here it is enough to have one condition inside the if statement which is true for the overall if statement to be true and to print pass. And let me tell you how it works in programming. Here, for example, in the second scenario, it will check first the final grade. If the final grade is greater than or equal to 50, if it is true, and we have here the AND operator, it will then check on the second condition. If the midterm grade is greater than or equal to 30, and if both are true, then it will actually, the overall condition will be true and it will print pass. However, if it checks final underscore grade variable and it was not true, the condition was not true, it was not greater than or equal to 50, it was false, and it was followed by an AND operator, it will not check anything after the AND, because since the first condition is already false, the overall condition will be false. I do not need to check the remaining conditions. So it will automatically evaluate to false and go to the else part even before or without checking the remaining conditions in the if statement, because the first condition is false. Here, if we move to the third scenario, inside the if condition, it first checks whether the final grade is greater than or equal to 50. If it is greater than or equal to 50 and it evaluated to true, it will automatically move to printing pass, because here we have the OR operator and it only requires one of the conditions to be true. So if the first condition is already true, I do not need to check on the remaining conditions. It does not check them, it skips them, and it goes directly to the then part and execute the action or the statements if the overall condition is true, which in this case is printing pass. However, if the final grade is not greater than or equal to 50, so it evaluated to false, and we here have an OR operator, it will then check on the second condition. Because here in an OR statement, or if we use an OR, we at least require one of the conditions to be true. So if the first condition is false, the second condition can be true, and then the overall statement or overall condition can be true. So even if the final grade is not greater than 50 and we use an OR operator, it will check on the second condition. Maybe it will be true and the overall condition will be true. And now let's create a totally different scenario that combines the first scenario and the second scenario together. And we are going to call it the fourth scenario. So first, let's comment the third scenario and let's uncomment the first scenario. As you recall, the first scenario, the student must score a total of 100 or more in the course. So we add the midterm grade and the final grade together. And if the total is greater than or equal to 100, we print pass. Otherwise, in the else, we print fail. Here in the second scenario, we have two conditions, and both conditions must be true for the overall condition to be true. So the student must score a grade greater than or equal to 50 in the final exam, and also they must score a grade greater than or equal to 30 in the midterm exam for the overall condition to be true. And now the fourth scenario will be as follows. For a student to pass the overall course, they either need to get a total grade of 100 or more, that's the first scenario, or they actually must score a grade greater than or equal to 50 in the final exam and a grade greater than or equal to 30 in the midterm exam to pass the course. So one of the two scenarios is enough for the student to pass the course. Either we add both grades together, and if it is greater than or equal to 100, then congratulations, the student passed the course. Or if it is not greater than or equal to 100, it was less than 100, then there is a second option which allows the student to actually pass the course, which is the second scenario. So we can write it, the student must satisfy one of two scenarios, which is one or two, to pass. How can we implement it? We can write if. The first scenario is if the total is greater than or equal to 100. That's the first scenario. If it is true, then the student passed the course. If it is false, there is still a second chance for the student to pass the course, which is the second scenario. So since there are two options, we use the or operator and not the and operator. Here or, and we add the second scenario condition. Final underscore grade greater than or equal to 50 and the midterm underscore grade greater than or equal to 30. So here, if the student did not score a total grade greater than or equal to 100, we can check on the final and the midterm grades individually. If the final grade is greater than or equal to 50 and the midterm grade is greater than or equal to 30, if both inner conditions inside the second condition. So here we have the second scenario or the second condition, which consists of two inner conditions. Both must be true for the second condition to be true. Here we say print pass, else we say print fail. Now let's try our code with different examples, but this time we want to see the behavior of our code from a programming point of view and not a human point of view. Because if you remember in the second and the third scenarios, we actually compared the midterm exam grade and the final exam grade to the conditions inside the if statements. But afterward, I told you that Python does it in a different way. For example, in the second scenario, where we have an AND operator, it checks the first condition. If it is false, it will no longer check the remaining conditions, because if I have an AND operator, the overall condition can be true in only one case, where all conditions are true. And if the first condition is false and I have an AND, there is no need to check on the remaining conditions because the overall result will be false. Therefore, we will also try this approach when we actually trace our values in the fourth scenario. Let's first comment the second scenario, and let's comment the first scenario, but we are going to keep the total variable because we need it. Let's click on run. The midterm exam grade, let's input 60, and for the final exam grade, let's input 70. Here it printed out pass because let's see what Python does. 60 plus 70 is 130. We check, is the total, which is 130, greater than or equal to 100? Yes, it is true. Therefore, the first condition in the if statement is true. And since here I have an or statement, and for an or statement, for the condition to be true, at least one of the conditions must be true. And since the first condition is true, therefore the overall condition will be true and it will print pass. What if I input as the midterm exam grade 40 and the final exam grade I input 50? It here printed out pass because 40 plus 50 is 90. So Python will check, is 90 greater than or equal to 100? No, it is less than 100. So the first condition is false. However, since I have an OR operator, it will check on the remaining conditions. Maybe one of them is true. So we are going to check on the second condition, which actually has two inner conditions. So here in the second condition, is the final grade, which is 50, greater than or equal to 50? Yes, it's equal to 50. Therefore, the first inner condition and the second condition is true. And since here I have an AND statement, both inner conditions must be true for the second condition to be true. So we are going to check on the midterm grade. Is 40 greater than or equal to 30? Yes, it is greater than or equal to 30. So the second inner condition is also true. Since both inner conditions are true, therefore the second condition in this big if condition is true, which means that since the first condition is false, but the second condition is true, and we have an OR, and we only need one condition to be true, therefore, this if statement will evaluate to true, and it will print pass. And now let's have our last example. If we click on run, let's input 20 as our midterm exam grade and 10 as our final exam grade, and we can see that it printed out fail, because 20 plus 10 is 30. 30 is not greater than or equal to 100, so the first condition is false. However, since we have an OR operator, we can check on the second condition. Maybe it's true and the overall condition evaluates to true. In the second condition, we have two inner conditions. So we are going to check, is the final grade greater than or equal to 50? Is 10 greater than or equal to 50? No. Therefore, the first inner condition and the second condition is false. And since we have an AND operator, we require both inner conditions to be true for the second condition to be true. And since the first inner condition is false, we no longer need to actually check on the second inner condition, because now automatically the second condition is false. And since the first and second condition both are false, we go to the else statement, since the overall condition will also be false, and we print fail. And if you remember at the beginning, I told you that there are multiple ways to create conditional statements. For the fourth scenario here, this was an efficient and optimal way to create the fourth scenario or to implement the fourth scenario by having one big if condition, which consists of two main conditions inside it, separated by an OR operator. However, we can actually implement the fourth scenario using a different implementation, but it will also have the same functionality. It won't be as efficient as this implementation, but if you recall the if, elif, and else statements that we used in the grading scheme example, we can actually use them to implement the fourth scenario. But we will have more lines of code compared to this implementation. So let's try it out. Let's here say if the total is greater than or equal to 100, then we have our colon, means let's print pass if the condition is true. So here at the beginning, we only checked on the first main condition. If the total grade is greater than or equal to 100, we are going to print pass. Otherwise, we are going to write here or use the elif statement, which means else if check on another condition. The second condition will be whether the final underscore grade is greater than or equal to 50 and the midterm grade is greater than or equal to 30. So if the first condition is not true, let's check on the second condition. If it is true, we are going to print pass. And as you can see, here we have more lines of code. We have redundant code. The print pass is actually written twice, so it is redundant. However, this is one of the implementations of the force scenario. If the second condition is not true, therefore we fall to the else part, which otherwise we are going to print fail, because neither the first condition or the second condition are true, therefore the student failed the course. And let's actually try this example, but let's comment the first implementation. Let's click on run. Enter the midterm grade. Let's enter 60 as the midterm grade and 70 as the final exam grade. And as you can see, it printed pass because 60 plus 70 is 130. Therefore, we are going to check, is 130 greater than or equal to 100? True. Therefore, we are going to print pass and then exit this if block code or this conditional code. Let's try another example, but this time, let's enter for the midterm grade 40. And for the final exam grade, we are going to enter 50. As you can see, it printed pass because 40 plus 50 is 90. 90 is not greater than or equal to 100. So we go to the elif statement and check on the second condition. Is the final grade greater than or equal to 50? Yes, it is equal to 50. So here, the condition, the first part is true. And since we have an AND operator, we must check on the second condition. Is the midterm greater than or equal to 30? Yes, because it's 40. Therefore, since both conditions in this elif statement are true and they are actually separated by an AND operator, the overall condition will be true, so it will print pass. What if we click on run and let's add, for example, 20 as the midterm exam grade and here 30 as the final exam grade? As you can see, it printed out fail because 20 plus 30 is 50, which is not greater than 100. So the first if statement fails. We move to the second if statement, which is in the elif. The final grade is not greater than or equal to 50 because it's 30. And the midterm grade is not greater than or equal to 30 because it's 20. And here, actually, since we have an AND operator, Python, for efficiency, only checks the first condition at the beginning. If it fails, it no longer checks the remaining conditions. And since the final grade is not greater than or equal to 50, so it skips checking the remaining conditions and says, well, this overall if statement will be false. So we move to the else statement and print fail. And here, this implementation was possible because we only wanted one of the two conditions to be true for the student to pass the course. As you can see in the first implementation, we used an OR operator. Either the first condition is true or the second condition is true for the student to pass the course. Therefore, in the second implementation, we used the if, elif, and else statements because here we can check at the beginning on the first condition. If it is false, still there is a possibility for the student to pass the course if the second condition is true. So here we have the elif statement which checks on the second condition. If it is false, therefore we go to the else statement and print fail because neither the first condition or the second condition are true for the student to pass, and we only need one of them to be true. However, if both are false, therefore there is no possibility for the student to pass the course. Now, let's have an interesting scenario, which will be a modification on the fourth scenario. Let's have the fifth scenario, and this time you are going to modify the fourth scenario as follows. The student must satisfy this time the two scenarios, 1 and 2, to pass. So instead of needing only one of them to pass, no, this time the student must actually satisfy both scenarios for them to pass the overall course. We can do it in an efficient and optimal way, like the first implementation of the fourth scenario. We can have something like this. If the total is greater than or equal to 100, and this time, instead of using an OR operator, since we must satisfy both scenarios, the two scenarios, we use the AND operator. Here, the final grade is greater than or equal to 50, and the midterm grade is greater than or equal to 30. If so, we are going to print pass, else we are going to print fail. So as you can see here, since in the fifth scenario, both scenarios must be satisfied, scenario 1 and scenario 2, for the student to pass, so the grade must be greater than or equal to 100, and also we need to check on the individual grades of the exams. You need to pass the final exam by scoring a grade greater than or equal to 50, and pass the midterm exam by scoring a grade greater than or equal to 30. So let's have an example. If we click on run, but before clicking on run, we need to actually comment this code, the second implementation of the fourth scenario, and let's click run again. Enter your midterm exam grade. Let's enter, for example, 40, okay? And enter your final exam grade. Let's enter 50. As we can see, it printed fail because 40 plus 50 is not greater than or equal to 100. Although they individually passed the midterm exam grade, they scored more than 30 or more than or equal to 30, and they also passed their final exam grade. They scored 50, which is the bare minimum to pass the final exam. However, the total was not 100. Therefore, they did not pass the overall course. What if we have something like this? Here, the midterm exam grade was 20, but in the final exam grade, they scored 90. They also failed because although 90 plus 20, it's 110, which is greater than or equal to 100. However, they only passed their final exam. They scored 90, which is greater than or equal to 50. However, for the midterm exam, they scored 20, which is less than 30. Therefore, they failed their midterm exam grade. They passed their final exam grade, even if the total grade is more than or equal to 100. But since they failed their midterm exam grade, it means that they failed the overall course. Let's try now an example that will print pass. Let's input 60 as the midterm exam grade and 70 as the final exam grade. And as you can see, it printed out pass because 60 plus 70 is 130. Therefore, the total is greater than or equal to 100. The first condition is true. And since here we have an AND operator between both conditions, it means that both conditions must be true for the overall condition to be true. So we are going to check on the second condition, which consists of two inner conditions. The first inner condition, the final grade, which is 70, is greater than or equal to 50, which is true. And the second inner condition, the midterm grade, which is 60, 60 is greater than or equal to 30. Therefore, since also the second condition here has an AND, so the inner conditions, both of them must be true for the second condition to be true. And since both of them are true, the second condition is now true. And now, since the first and second conditions are true, and we have an AND operator, therefore the overall condition is true and will print pass. We can have here a quick hack. Since we have an AND operator here, and also in the second condition, the inner conditions are separated by an AND, we can just simply remove the brackets. So here we can remove this bracket, and we can remove this bracket and say, well, we can have one big condition, which is the total grade is greater than or equal to 100, and the final grade is greater than or equal to 50, and the midterm grade is greater than or equal to 30. So if we click on run and we enter the previous example, 60 and 70, it will print pass. If we enter, for example, the 20 and 90, it will print fail. Because here, instead of having two main conditions and the second condition consists of an inner condition, well, we can just have one big condition that consists of three terms, and they are separated by ANDs. And it was possible to remove the brackets because here we had an AND and an AND. However, if they were different operators, for example, this was an OR, then we need to return the brackets back because now we have two different operators, an and an OR. So we need to have the brackets to actually know the scope of each conditional statement. But since both were ANDs, we can just remove the brackets. Now, here we implemented the fifth scenario using an efficient and optimal way. However, we can implement it using a non-efficient way, but this way may be useful in other scenarios. How can we do so? here we are going to introduce the concept of nested if statements. Let me show you how can we use the nested if statements. Let's write if, followed by the total is greater than or equal to 100. If this condition is true, it is not enough to print pass. We need to check on the second condition because it's important for both conditions or both scenarios to be true for the student to pass the course. Let me here return the brackets so it is more readable or for better readability, since here the second implementation will depend on this concept of readability. So here, if the total is greater than or equal to 100, if it is true, it is not enough to print pass. We need to check on the second condition. So here, if we click on enter, we can write an if statement, another if statement. And that's why it's called nested if, because we have a big if statement and inside it we have another if statement if the condition is true inside the then part. So here we can say if the final underscore grade is greater than or equal to 50 and the midterm underscore grade is greater than or equal to 30. Here, if this second condition is true, we are going to print pass. Otherwise, if it is not true, we are going to print fail. And if actually the total is not greater than or equal to 100, we need to print fail. And now you are lost with the multiple if and else statements. Let's have some spaces to actually, or some new lines to understand the difference. Now let's trace our new implementation. Here in this if statement, the big one, we are checking on the first condition, whether the total grade is greater than or equal to 100 or not. If it is not greater than or equal to 100, we go directly to this else statement and print fail, because this else statement is on the same indentation level as this if statement. Therefore, this is the else part of the big if statement. Here, if we write a comment and say first condition, then this else statement on line 66, it is the else of the first condition. Okay? So if the first condition is not true, I will go to the else of the first condition and print face. However, if the first condition is actually true and the total grade is greater than or equal to 100, we then go to the then part of the if condition. And here we have the indentation. So here, the indentation means we are inside the then part of this if condition. And we must check on the second condition because in the fifth scenario, both conditions must be true for the student to pass the course. So if the first condition is true, we must check on the second condition. Let's write a comment here and say second condition. If the second condition is not true, we are going to this else statement, which is the else of the second condition on line 63. If the second condition is not true, we go to line 63, the else part, and print fail, which means this fail means that, well, the first condition was true, but the second condition was not true, and therefore the student did not pass the course. However, here, if this second condition is true, then we will print pass because the first condition is true, therefore we went to the then part of the if statement, and inside the then part of this if statement, inside its body, we wrote another if condition. That's why we call it a nested if, because we have a bigger if and then an inner if statement. And if this condition, the second condition, is true, we print pass because now the first condition and the second condition both are true. And as you can see, we can know which else statement belongs to which if statement based on the indentation level. So first, let's comment the first implementation of the fifth scenario, and let's focus more on the second implementation and the concept of indentation. Let's also remove all of the spaces we have here, and also here, and also here. And let's actually create the indentations from scratch. First of all, we have the first condition. if the first condition is true, we need to check on the second condition. So we need to go to the body of the if statement and check on the second condition. How can we identify that the second condition, which is this line, is inside the body of the first condition? By moving it one tab to the right. So now Python knows that this if condition will only get executed if the first condition is true, because it's inside the body of the then part of this if statement. Now, we are going to check on the second condition. If the second condition is true, it means that, well, the first condition was true, therefore we checked on the second condition, and the second condition is now true, so the student passed the course, and we need to print pass. So we need to move this print statement into the body of the second condition, which means we need to move it 2 tabs to the right. Here, now it belongs to the body of this if statement. It is in the then part of the second condition. Now, we have here the else statement of the second condition. And if the second condition is not true, we need to actually print fail. We need to have an else part. So we move this else statement one tab to the right. Now it is aligned with the second condition, which means this else statement belongs to this if statement. It is the else part of this if statement, which is the second if statement. And if the condition is false, we go to the else statement and we want to print fail. So here we need to move it 2 tabs to the right. So now it is in the body of the else statement. What if the first condition is actually false? We need to go to the else part of this first condition, which is this else statement on line 66. And as you can see, it's already on the same indentation level as the if statement on line 59. So it means that this is the else part of this if statement. However, we need to move the print statement one tab to the right to be inside the body of the else statement and print fail. Now let's try some examples and see if our code will behave correctly or not. Let's click on run. Let's input our very basic example, 60 as the midterm exam grade and 70 as our final exam grade. And as you can see, it printed pass because here, first it checked on the total, which is 130. It's greater than or equal to 100. So it will go to the body of this if statement, which is the then part. Then it has another condition. It will check here, the final grade 70 is greater than or equal to 50. And 60 as the midterm grade is greater than or equal to 30. Therefore, it will print pass and then it will exit this conditional block. However, if we write something like this, we have 40 as the midterm exam grade and here 50 as the final exam grade. As you can see, it printed fail. However, which print statement was executed? Whether it was the fail on line 64 or the fail on line 67, let's trace and see. Here, 40 plus 50, it is 90. So 90 is not greater than or equal to 100. So it went to the else part of the if statement on line 59, which is the else part on line 66, and printed fail. However, if we click run, let's have 20 as our midterm exam grade and 90 as our final exam grade. Here, it also printed fail, but this time, this fail is different from the previous fail because here it executed the fail on line 64. Because if we trace it, 90 plus 20 is 110, which is greater than or equal to 100. So we go to the then part of the if statement and check on the second condition. The final grade is actually greater than or equal to 50. However, the midterm grade is less than 30 because it's 20. So we go to the else part of this if statement. The else part of this if statement is the else on line 63. So here it printed fail from line 64. And if you remember, I told you before, we could have multiple statements inside the body of the if part. Like here, we have many statements, and also we could have multiple statements inside the body of the else part. However, we have here only one statement, but it is possible to have multiple statements. Now, let's add a third implementation for the fifth scenario, and this time we are going to swap the first condition and the second condition together. Let me show you. Here we write if, and then I'm going to check on the second condition first this time. Final underscore grade greater than or equal to 50, and midterm underscore grade greater than or equal to 30. So here I'm going to check on the second condition. If it is true, I'm going to check then on the first condition inside the body of this if part. However, let's assume we do not have the total variable. Let's comment it here, and let's comment the second implementation. And let's assume we do not have the total variable. We need to recreate it. So inside the body of the if part, if the condition is true, I'm going to say total equal midterm underscore grade plus final underscore grade. Here, the addition of the midterm grade and the final grade will be stored inside the total variable. And now I can perform the condition of total greater than or equal to 100. If it is true, then here the condition in the first if statement is true, the condition in the nested if statement is also true, so we are going to print pass. Otherwise, if the total is less than 100, I'm going to print fail. And what if the condition in the first if statement is actually false? We go to this else statement, which is aligned, the indentation is aligned with the first if statement, because this else part is actually related to the very first if part. And here we say else, print fail. And let's have an enter here for readability. So here, I'm just showing you that we can have other type of statements inside the body of the if or the else. Here, we could assign variables, we could perform arithmetic operations, we could have if statements, we could have print statements, we could have any type of statements inside the body of the if part or even the else part. Let's here, for example, have another print. Print, yes, you failed. So fail and yes, you failed. We can print anything. And let's actually try it. Let's click on run. Enter your exam grade. Let's enter our typical example, 60 for the midterm and 70 for the final. As you can see, it printed out pass, because first it will check the final grade, 70 is greater than or equal to 50, and the midterm grade, 60 is greater than or equal to 30. Therefore, both are true. Since we have an AND operator, the overall condition will be true. We go to the body, we calculate the total, which is 60 plus 70, 130, which will be stored inside the total variable. Then we are going to check the value inside the total variable. Is it greater than or equal to 100? Yes, it is. So we are going to print this pass. Let's actually have something else like this. Enter the midterm exam grade. It's 20, and the final exam grade is 10. Here it printed fail, and it also printed yes, you failed. So we checked on the condition in the first if statement, it was false. Therefore, we went to this else part and we printed both statements. And here it shows you that we can have multiple statements inside the body of the else part. Let's have something where the total is not greater than or equal to 100. So here, for the midterm exam grade, let's have 40, and for the final exam grade, let's have 50. Here, it just printed fail, because yes, the final exam grade is equal to 50, which is the bare minimum. The midterm grade is greater than or equal to 30. So we go to the body, we calculate the total, 40 plus 50, which is 90. However, 90 is not greater than or equal to 100. So we go to the else part and only print fail. And now let's play a nice game and let's build our first Python program. First of all, we are going to delete everything here and let's start from scratch. Our first program will be a calculator program where the user will input two numbers and an arithmetic operation sign. And based on this arithmetic operation sign, we are going to perform an arithmetic operation on the two numbers provided by the user. Here, let's take our first input, first underscore number equal, it's an integer input, enter the first number, and then followed by the operation sign, which is a character or a string. So we are going to deal with it as if it is a string, input, enter the operation sign. Then here we will have the second underscore number, which is an integer input, enter the second number. So the user will input the first number, followed by an arithmetic operation sign, and then the second number. And we want to perform an operation on both inputs based on the sign or the value inside the operation variable. First of all, let's create a variable called result equals 0, which will contain the result of our arithmetic operation. And we can actually build this program using simple if, elif, and else statements. Let's start with an if statement. If the operation is equal to an addition sign, and as you can see here, we have the operation variable. We used the equal to comparison operator, and then we are comparing it to a string that contains the symbol or the letter or the character plus. And since the operation variable takes a string as an input, we are comparing the plus sign, we put it inside double quotations, because here we are comparing a variable that contains a string with a string value. If it is the plus sign, then the result will be first underscore number plus second underscore number. What if it is not a plus sign? We can use an elif statement. Here, operation equal or equal to, we can have the subtraction sign, the minus. And this time, the result will be first underscore number minus second underscore number. What if it is, for example, a multiplication sign? Here we use another elif statement and we compare the value inside the operation variable with the asterisk or the star, which is the multiplication symbol. And the result will be the first underscore number multiplied by the second underscore number. Let's actually do it for the remaining operations. So we can say here, for example, elif operation is equal to the normal division, and don't forget the colon after the statement, and the indentation, of course, first underscore number divided by second underscore number. That's a normal division. However, if we had an integer division which uses 2 forward slashes, then we will perform an integer division. First underscore number, integer division, second underscore number. We can have the power, which is operation is equal. If we use double asterisks or double stars, it means the first number to the power of the second number. Result equal first underscore number to the power of the second underscore number. Finally, we have the remainder operator. So the operation is equal, and here we use the percentage sign, which means we want to calculate the remainder. The result here will be first underscore number, remainder, second underscore number. And now, since we are done with our arithmetic operators, we can have our else statement, which will print invalid operation. Because if actually the operation, the value inside the operation variable did not match any of these if statements, it means the user input an incorrect symbol or sign, so we are going to print invalid operation. And outside of this conditional block, we are going to print our result variable. So let's actually print it outside of the conditional block. We can say the result is followed by the result variable. Here we initialize the result variable by 0, and according to the operation value, which is the arithmetic operator symbol that is present or stored inside the operation variable, according to it, we are going to perform an arithmetic operation. However, if the user input an invalid operator, we are going to print invalid operation. However, in both cases, the result will be printed because the print statement is outside of the conditional block. So whether we have a valid operation or an invalid operation, we will print the result. Let's actually try with few examples. Let's start with the addition. Here 2 plus 3, and as you can see, it printed out 5 because it checked on the first condition and actually the value inside the operation variable, which is a plus sign, is equal to the plus sign. So we perform an addition, we exit this conditional block, and then we print the result, which is 5. Let's try it with a subtraction example. Here 5 minus 3, and as you can see, we have the output as 2. Because the first condition is false, it is not a plus symbol. However, the second condition in the elif is true because it is a minus symbol, a subtraction symbol. So we perform the subtraction operation and then we print out the result. Let's have one more example. Here, 2 multiplied by 3, which is 6. It printed out 6 because the first condition is false, the second condition is false. However, the third condition is true. The asterisk, which is the value stored inside the operation variable, is actually equal to the asterisk, which is the value that we compare the value inside the operation variable to. Here, we perform a multiplication and then we print the result. Let's try it quickly with the other operations, but without explaining them. So here, for example, if I say 5 normal division by 2, it printed out 2.5, which is this condition. But if you want to do an integer division, we say 5 integer division by 2. Here, it printed out 2, which is this condition. What if we click on run, and this time we want to use the exponentiation, which is to the power of, let's say, for example, 5 to the power of, which is 2 asterisks or 2 stars, 2. Here it printed out 25 because 5 to the power of 2 is actually 5 times 5, which is 25, which is this condition. This condition was true, therefore we performed the power operation. And finally, let's do the remainder. 5 remainder 2, the result should be 1, and as you can see, it printed out 1 because it matched to this condition and performed this operation. However, if we input an invalid arithmetic symbol, like for example here, let's say 5, and let's enter the character P, for example, then 2, it will print out invalid operation because it went to the else part, and then it also printed the result is 0, which is the initial value of the result variable, which is 0. What if we want to only have one print? We do not want to have both printing statements. We can have something like this. Here, instead of printing invalid operation, we can say the result equal, and we create a string inside it, invalid operation. So here, instead of having an integer value inside the result variable, we are going to change its type and actually assign a string value to this variable. Let's see the behavior. If we click on run, let's do a simple arithmetic operation first, which is 2 plus 3. Here it printed the result is 5. But if we do something like this, 2, then I enter another character, for example, K, then 3, here it printed the result is invalid operation because we changed the nature or the type of the result variable from int to string. And it is very simple to do so in Python. You just say, instead of, for example, result equal a particular integer value, you say result equal a string value like this string between double quotations. And here, the print statement, it will print whatever value inside the result variable, whether it's an integer or a string. Now, what if I tell you that we can write this program in a simpler way? Instead of using the if, elif, and else statements, we can use something that is called the match case statement. And sometimes in other programming languages, it is called the switch case statement. Basically, it's a type of conditional statements which allows us to match a variable's value against a set of patterns. Let's see how can we implement our program using this match case statement. First of all, we write match, followed by the variable name that we want to check. Here, we are always checking on the operation variable. So we write after match, we write the variable name, which is operation, followed by a colon. Then When we click enter, as you can see, we have one tab which is right indented, because now we are inside of the body of this match statement, and we will write our different cases. So basically, we write the keyword case followed by the value that we want to compare the operation variable to. For example, in this if statement, the first one, here we were comparing the value inside of the operation variable to the plus sign, which is a string. Here, after we wrote case, we will write our plus sign inside of double quotations because it's a string. So here, as if we are comparing the value inside of the operation variable to the plus sign. If the case is a plus, so the operation variable contains a plus, we will perform the following action, which is inside of the case statement body. This time, we will perform an addition. So result equal first underscore number plus second underscore number. And we can have multiple statements inside of the case body, like we did inside of the if or the elif or the else statements bodies. What if we want to add another case? Take care of the indentation levels. As you can see, this case, as I said, it's one tab to the right indented because it's in the body of this match statement. However, as you can see, this result or the addition statement, it is two tabs to the right indented because now it is in the body of the case statement. It will only get executed if this case statement is true, which means that the value inside of the operation variable is a plus sign. Now, if we want to create another case statement, we must make sure that it is indented correctly on the same indentation level as the previous case statement. And for example, let's compare it to the minus symbol. And this time it means that we want to perform a subtraction operation. We can simply say result equal first underscore number minus second underscore number. We can do it for the remaining symbols. So for example, here we can have a case for the multiplication, and if it is true, I can just copy this and simply paste it here. We can have a case for the division, and we can copy the division operation and have it here. As you can see, it is inside of this case statement, not inside any of the other case statements. So this line will only get executed if the value inside of the operation variable is a division. And after the normal division operation comes the integer division operation. But first, let me show you a mistake that some people fall into. If I put my cursor after the second underscore number variable and I hit the enter key, as you can see, now my cursor is on the same indentation level as this normal division operation. So if I write case followed by the integer division symbol, as you can see, this case statement is now inside of the normal division case statement, which is incorrect. So we need to actually move it one tab or one space to the left. And to do so, we hit the backspace key like this. Then we click on enter, and then we copy our integer division operation. As you can see, when we copied and pasted the integer division operation, sometimes the indentation goes off like this. So we need to fix the indentation. Here, it must be two tabs to the right if our reference is the match statement, or one tab to the right if our reference is this case statement. Now, let's have the power case. Let's copy and paste the operation. And here the indentation was actually correct. Then let's have the remainder case, which uses the modulus operator. Let's copy paste it. And as you can see, the indentation here was also correct. And now we are done with our arithmetic operators. However, we still need to write this else statement inside of our match case statement. How can we do so? If you remember, we actually execute the body of this else statement if the value inside of the operation variable did not match any of our previous cases, which are the arithmetic operators. To do so in the match case statement, we actually create a new case, and then inside of this case, we write underscore followed by a colon. Here, Python knows that if none of the previous cases match, we will fall into this case and execute whatever it is containing, or whatever line of code or operations this case statement contains. Here, we will have result equal invalid operation. And outside of our match case statement, we will print the result is followed by the result variable, as you can see. And we can comment the first implementation. We still have the result is equal to 0, the initial value. And here we have our different cases inside of the match case statement. So now let's try this implementation with multiple examples. Let's click on run. Here, enter the first number. Let's enter 2. The operation is a plus, followed by a 3. And as you can see, the result is 5. Because here, we have match operation. So it will try to match the value inside of the operation variable to one of these cases. And here, since we have the plus sign inside of the operation variable, it matched to the first case and it performed the addition operation, and then it exited this match case statement and printed the result. Let's try it with the other arithmetic operators. For example, 5 minus 3, the result is 2. Let's have 2 multiplied by 3, the result is 6. What if we want to have 5 normal division by 2, the result is 2.5. However, this time, if it is an integer division like this, then the result is 2. If we want to have 5 to the power of 2, it's 25, followed by 5 modulus 2, which is 1. So as you can see, all of the arithmetic operators were matched correctly to our cases. What if we input an incorrect symbol? Let's, for example, say 5 and an AND symbol followed by 2. As you can see here, it printed the result is an invalid operation because this AND symbol is not one of the cases we have. So it went to the default case, which is case underscore, and assigned the string invalid operation to the result variable. And as I said before, we could perform multiple operations inside any of these case statements. For example, for this case statement, we could actually have more than one operation or multiple lines of code inside its body, and they will get executed if the value inside of the operation variable matches this plus sign. And as you can see in this particular example, which is the calculator program, it is better to use the match case statement compared to the if, elif, and else statements. If we uncomment the first implementation, we can see that the match case statement, it's direct and a straightforward implementation. We just write match followed by the variable name, and then we have our different cases, since the idea of this example is to compare the operation sign to the value inside of the operation variable. So it's straightforward to write case followed by the arithmetic sign, and if it's a match, we perform the operation directly. However, here in the if, elif, and else statements, we used to actually write the comparison ourselves. We write, for example, if the operation is equal to plus, and if the operation is equal to minus, etc., which is not a straightforward implementation or way to actually write this program. Therefore, it is just easier to use the match case statement instead of the if, elif, and else statement for this example. However, There are other examples where it is better to use the if, elif, and else statements compared to the match case statement. One of them is the grading scheme example we had before, where the user provided us with their grade and then we printed out whether they scored an excellent grade or a very good grade or a good grade, etc. Let's just try to implement it using the match case statement and compare it to the if, elif, and else statements and see why it is a bad option to use the match case statement for this grading scheme example. So we are going to delete everything and create a new variable called grade, which will be an integer input, and we will ask the user to enter your grade. Now we are going to write our match case statement by saying match grade. And as you can see here, we want to compare the value inside of the grade variable with the multiple cases. Previously, when we used the match case statement, we were comparing whether two values are equal to each other or not. If we say, for example, match operation in the previous example, we were comparing whether the value inside of the operation variable is equal to one of the arithmetic signs. So we simply wrote case followed by the arithmetic sign that we want to see whether it is equal to the value inside of the operation variable or not. But here, since our first scenario or case will be whether the grade is greater than or equal to 90, then we print excellent. How can we do it using the match case statement? We can write case followed by a temporary variable name. Let's call it temp underscore grade. And then we say case temp underscore grade if temp underscore grade is greater than or equal to 90, we print excellent. Here we have temp underscore grade, which is a variable. This variable will contain the value inside of the grade variable. However, we are going to perform a comparison operation on this temporary variable by checking whether it is greater than or equal to 90 or not. If it is true, we are going to print excellent, because we cannot use the grade variable directly inside of this comparison. Okay, we need to actually put it inside of a temporary variable so we can perform the comparison operation. For example, the other case, we can say case temp underscore grade. If the temp underscore grade is greater than or equal to 80, we print very good and take care of the indentation. Okay, as you can see, here we have our match statement. Then one tap to the right, we have our cases, and then two taps to the right with our match statement as the reference is the body of each of the case statements, or one tap to the right if our reference is the case statement. So let's continue with our cases. Here, case temp underscore grade. If temp underscore grade is greater than or equal to 70, we print good. Then we have case temp underscore grade. If temp underscore grade is greater than or equal to 60, we print satisfactory. Then we have case temp underscore grade. If temp underscore grade is greater than or equal to 50, we print pass. Then otherwise, which is case underscore, we will print fail. As you remember, the else part is translated inside of the match case statement as an underscore, case underscore, and then we write the statement inside of the previously implemented else part. We write it here inside of the case underscore body. And as you can see here, the value inside of the grade variable was binded to a new variable, which is a temporary variable called temp underscore grade. And then we used a guard, which is this if statement, for the comparison, because we cannot use the grade variable directly inside of the comparison. So we had to actually bind its value to a temporary variable and then use the temporary variable for the comparison. Now, let's try this implementation with examples. However, let's add here a space for readability. Let's click on Run, enter your grade. If we enter 95, it prints out excellent. Because as you can see, here we match the grade, which is 95. The first case is we actually put the 95 inside of this temporary variable, which is temp underscore grade, and then compare whether 95 is greater than or equal to 90. It is greater than or equal to 90. Therefore, we print excellent, and then we exit this match case statement block. Now, if we try it with other values, for example, 81, it prints out very good. If we try it with 70, it prints out good, because here the condition is greater than or equal to 70, and 70 is actually equal to 70, so it prints out good. If we try it with, for example, 68, it prints out satisfactory, and if we try to input 51, it will print out pass. However, if we try to input 22, it will print out fail, because 22 did not match any of the cases we have. Therefore, it went to the default case, which is the case underscore, and then it printed out fail. As you can see, this implementation using the match case statement, it is not as direct or straightforward as the if, elif, and else statements implementation. If you recall the if, elif, and else statements implementation, we used to write if grade greater than or equal to 90, we print excellent. If the grade is greater than or equal, for example, to 80, we print very good, and so on. As you can see, this is a simpler implementation compared to the match case implementation for this particular scenario. Because in the match case implementation, we had actually to bind the value inside of the grade variable into another variable, a temporary variable called temp underscore grade, and then we used this temporary variable inside of our if condition. So it's more of a complicated procedure. However, if we directly used the if, elif, and else statements, it is a more of a straightforward way to implement this grading scheme example. And since we were talking a lot about conditional statements, let's move on to a different topic, which is an easy and a light topic. This topic will be some hacks in Python. Let's remove everything and start from scratch. Let's assume we have a variable called first underscore number, and we assign it to the value 5. So now the value 5 is stored inside this variable. And we can have another variable called second underscore number, and we can assign it to the value 2. Now, let me show you some hacks in Python. I could say, for example, first underscore number plus equal second underscore number. What does this statement mean? This statement means first underscore number is equal to the first underscore number plus the second underscore number. So when I use plus equal here, as if it performs the following operation, it will take the variable first underscore number and add it to the second underscore number variable, and then it stores the result in the first underscore number. So if we create a print statement and say we want to print the first underscore number, and we click on run, as you can see, it printed out 7, because the first underscore number contains 5, the second underscore number contains 2, and here when we say the first underscore number plus equal the second underscore number, it will perform the addition of the first number and the second number, and then it stores the result into the first number. Therefore, the value inside of the first underscore number variable changed and became the addition value. What if we actually remove this print statement, and let's try it on different operations? For example, we can say first underscore number minus equal second underscore number. We can also have first underscore number asterisk equal second underscore number, so it will perform a multiplication operation. We can also have first underscore number divided equal second underscore number, or we can perform an integral division like this. We can also perform the power operation, which is like this, double asterisk equal the second number. Also, it can work on the remainder operation with percentage sign equal second underscore number. And let's print the first underscore number again. But this time, let's write comments for us. So here it is first underscore number equal first underscore number minus second underscore number. Since we have here minus equal, this time it is a multiplication operation. So we are going to multiply the first underscore number by the second underscore number. However, here we are going to perform a normal division operation. So we use the forward slash symbol for division. Here we want to perform an integer division, so we use two forward slashes. However, here we want to perform the power operation, so first number equal first number to the power of the second number. And finally, here we perform the remainder operation using the modulus operator, so it's first underscore number modulus second underscore number. Okay, and let's comment everything using the shortcut. If you remember, we highlight it and then we use control or command followed by the forward slash key. And let's uncomment the second operation, which is here the subtraction. If we click on run, 5 minus 2 is 3. As you can see, it printed 3. If we comment it again and then uncomment the third operation, 5 times 2, we're expecting 10, so the output is 10. Let's comment it and uncomment the fourth operation. Here it is a division, but a normal division. Therefore, the result should be 2.5. As you can see, it printed out 2.5. However, if we comment it and uncomment the fifth operation, it is an integer division, so the result should be 2. And as you can see, it printed out 2. Now here, if we comment it and uncomment the power operation, let's click on run. 5 to the power of 2 is 25 because it's 5 times 5. Let's comment it, and finally, 5 remainder 2, it should be 1, as you can see. Now, let me show you something different. What if we create a variable called text and we assign it to the string hello? What if we want to count the number of characters inside of this string, or basically know the length of this string? We can create another variable called text underscore length, for example, and then we use the len functionality, which is we write len, L-E-N, followed by brackets. And len is the abbreviation of length. And inside of the brackets, we write our variable name, which is text. Then we create a print statement and print the text underscore length variable. Since hello consists of 5 characters, its length is 5. So we expect Python to print 5, as you can see. Now let's make things even more interesting. Let's take an input from the user, which will be their name. So basically, we are going to create a variable called name, which is a string input, so str followed by input, and then we ask the user, enter your name. And then we want to print hello followed by the username, and we have a space in between them. We already have our variable, which is text equal hello. We do not need the length anymore, and we do not need this print statement anymore. We can create a new variable called introduction, and then we say that this variable will be assigned the text value, which contains hello, plus here inside of double quotations, we write a space followed by the name. And as you can see, when we use the plus when dealing with strings, here it concatenates the strings together. It puts them beside each other. So here we'll have hello followed by a space followed by the name. And we can simply print introduction. If we click on run, as you can see, it printed out enter your name. If I enter my name Walid, as you can see, it printed out hello Walid. And actually, there are multiple ways to implement this example. One could implement it inside of the print statement, saying, for example, here, print text plus, here we have space inside double quotations, followed by the name. And we can remove this variable. We just click on run. It will ask us, enter your name. I enter my name, and it will print hello Walid. Someone could say, well, I could, instead of using text, I could simply here say hello, followed by a space, and then plus the name to concatenate the name to this string. If I click on run, enter your name, it's Walid. And as you can see, it also printed out hello Walid. So there are always multiple ways to implement any functionality in programming. Do whatever you want to do. However, it's always good to use an efficient implementation and also one that anyone could easily read and understand. So for example, if I want to print the length of the username, I could simply say inside of the print statement, len followed by the name. If I click on run, enter your name, it's Walid, consists of 5 characters. As you can see, it printed out 5. If I click on run, and for example, I enter Tom, it will print out 3. So instead of using a variable called text underscore length or name underscore length, and I calculate the length of the string inside this variable and then print the variable, we could print the length directly without using variables. However, sometimes people prefer to use variables for better readability, and if you want to use this value multiple times across your code. And actually, we can also perform arithmetic operations directly inside of the print statement. For example, we could say 2 times 4 plus 3, and we can remove everything here, and we just print it. As you can see, it printed out 11 because first it will perform the multiplication operation, because if you recall the order of operations, multiplication is always the first. So here 2 times 4, it is 8, and 8 plus 3 is 11. If we just swapped it, so here if we said 3 plus 2 times 4, it will also result in 11. As you can see, because here the order of operations, the multiplication has a priority over the addition. So it will perform the multiplication first, 2 times 4, and then the result will be added to 3. If you do not know the order of operations, or you want a particular order to be executed first, we use brackets. Let me show you. Let's remove this example. Let's create a variable called result equal. And I have this operation, 3 plus 2 times 4. And I want to print the result. Okay? If I keep it like this, it will print 11, as we've seen before. However, if I say 3 plus 2 inside of the brackets, followed by times 4, and I click on run, as you can see, it printed out 20. Because here, when you use brackets inside of an arithmetic operation, it will give a higher priority to this operation which is being performed inside of the brackets. And here, it performed first 3 plus 2, which is 5, and then 5 times 4, which is 20. So if we add here 25 minus, and we click on run, as you can see, the output is 5. Because first, it will actually evaluate the operation inside of the brackets, which is 3 plus 2. The result is 5. Then, since we have here a subtraction and a multiplication, the multiplication has a higher priority over the subtraction, so it will perform 5 times 4, which is 20, and then it will perform 25 minus 20, which is 5. And actually, we can have brackets inside of the brackets. For example, here inside of the brackets, we have 3 plus 2. However, we can have another brackets inside of this brackets and say, for example, 2 minus 1. So as you can see, the outer brackets contains 3 plus, then we have the inner brackets which contain 2 minus 1. If we click on run, the result will be 9. Let's calculate this operation and see from where did the 9 come from. Since we have the outer brackets, this term will evaluate first. So 3 plus And then we have inner brackets. Therefore, we are going to evaluate the inner brackets. 2 minus 1, it is 1. And then we perform the 3 plus 1 operation, which is 4. Then since the multiplication has a higher order than the subtraction, we will do 4 times 4, which is 16. And then 25 minus 16 is 9. And we can actually replace any of these numbers with a variable or even multiple variables. For example, if we are going to take an input from the user and store it in a variable called number, it will be an integer input, and we'll ask the user to enter a number, as you can see. And here we can replace 25 by our new variable. If we click on run and enter 25, we should expect 9. As you can see, it printed out 9. However, if we enter 20, we will expect 4, because here 20 minus 16 is actually 4. Let's move on to a different concept and ask ourselves an important question. Can a variable hold multiple values at the same time? The answer is yes and no. This introduces us to the concept of lists in Python. For example, let's assume we have multiple pets in our home, and we want to store these pets, for example, a dog, a cat, and a bird, into a variable. How can we do so? If I create a variable called pets, and for example, I say it is equal to the string dog, now this variable contains the string dog. If I say pets equal cat, now it replaced the value inside of the old pets variable, which was dog, with a new value, which is cat. So now if we print this variable, as you can see, it will only print out cat. However, if I want my variable pets to contain two items, the string dog and the string cat, here we need to use lists. We say that the variable pets is assigned to a list, and to represent a list, we use square brackets. So now the data type of the variable pets, it's a list. It contains a value, and this value, it's a list. So it does not contain actually multiple values physically. It contains one value called a list, and inside of the list, we have our multiple items or elements. We can say, for example, using double quotations, we write dog. So here we have the first element, which is the string dog. Then if we write a comma, followed by our second item or element, which is a cat, a string called cat, and then we could have a third string called bird. And here, if I print pets, as you can see, it prints out the entire list, dog, cat, and bird. So what is actually a list? It's an ordered, mutable collection of items, as you can see. A container that can hold multiple values. For example, here it contains multiple strings, which can be of any data type. It could have strings, integers, other lists, floating point numbers, booleans, any data type. And the order in which he puts them is preserved. So it's an ordered list, as you can see. We insert dog, followed by cat, followed by bird. And when we printed the list, it printed them in the correct order. It is mutable, so we can change, add, or remove items after the list is created, and it is heterogeneous. A list can contain items of different types. And also, if we want to access a specific item or element inside of the list, we can do so. For example, if I only want to print the first element inside of the list, we can say here inside of our print statements, we write pets, and then we use square brackets, and we write the index of the item or element that we want to print. For example, if I want to print dog, its index is 0. Here we start with a 0 as the first index and not 1. It is 0 based. So dog is at index 0, cat is at index 1, and bird is at index 2. So if I want to print dog, it is at index 0, so I say pets of 0, and I click on run. As you can see, it printed out the string dog. If I want to print this time the second element inside of the list, here it is at index 1. So I replace the 0 with a 1, and as you can see, it printed out cat. However, if I want to print the third element in the list, which is at index 2, so if I change the index, as you can see, it printed out bird. So take care. Dog is at index 0, which is the first element. Cat is at index 1, which is the second element. And bird is at index 2, which is the third element. However, we could actually print it from the back. So here, if I say pets of -1 and I click on run, here it prints out bird because the negative index counts from the end. And this time, -1 refers to the last element in the list, which is bird. So I do not know how many elements in the list, for example. If I just use the index -1, it will start counting from the end of the list. And here it will print bird. If I say -2, it will print cat. And if I say -3, it will print dog. Now, what if we want to modify or edit an item inside of the list? We can do so by accessing the item using its index. But first, let's actually rewrite this print statement. And here we use F followed by the double quotations for the new modern printing technique. And we can say the original list is followed by here curly brackets, and inside it we write the variable name. So first we are going to initialize the list with 3 values, including dog, cat, and bird, 3 strings, and then we are going to print this list. Let's here close the double quotations. As you can see, it will print the list. Then we want to modify, for example, the first element in the list. We say pets of 0 equal, for example, horse. So as we can see here, we are trying to change the value of one of the elements. And this is the element or the item at index 0, which is dog. So here I'm going to replace the value dog, the string dog, by the string horse. So here the string horse is replacing the first element in the list, which is at index 0. So here if we say print, this time the new list is followed by curly brackets, and we close the double quotations. If I click on run, as you can see, here the original list is dog, cat, and bird. However, the new list is horse, cat, and bird because we changed the value of the first item in the list. What if we want to actually, this time, modify or change the second item in the list? Here it is at index 1. So we say pets of 1, we replace the 0 by 1. And if we click on run, as you can see, it replaced the string cat by the string horse. What if we want to change or edit the third item in the list? It is at index 2. So here we say pets of 2. And if we click on the run button, it replaced the string bird by the string horse. What if we want to add a fourth item to the list? For example, I want to add horse as a fourth item. Here we can say pets dot append. We are going to use the append function, and inside of it we write horse inside of double quotations, of course, because it is a string. So here we say pets, our variable name, which contains our list, followed by dot append. So here it means I want to append a new item to the list, and here it will append it at the end of the list. And here we want to append the string horse. So if I click on run, as you can see here in the new list, it printed out the dog, the cat, and the bird, and also it included the horse. We can also do something like this. And the list size is, and here curly brackets, and then we can use the len function. If you remember, when we wanted to know the length of a string, we used the len function. We can also use the len function to get the length of the list. This time it will tell me how many items are present inside of the list. Here we say len of pets, and we can do it in the second print statement, and the list size is inside of curly brackets, we say len followed by normal rounded brackets, and inside it we write the variable name. If we click on run, as you can see, here at the beginning, it said the original list is dog, cat, and bird, and the list size is 3 because it contains 3 items. However, here it says the new list is dog, cat, bird, and horse, and the list size is 4 because it contains now 4 items after adding the horse to the list. And now, what if we want to remove a specific value from our list? For example, I want to remove the string cat. How can we do so? We can simply write pets dot, then we write remove, and inside of our rounded brackets, we write the value that we want to remove from the list, which will be cat. So it will search for the string cat inside of our list, and it will remove it from the list. Let's have a print statement. However, let's modify the previous print statements. Let's make them shorter. For example, we could say here with size, and here also we could say with size. And let's actually copy paste this print statement. And let's click on the run button and see the behavior of our code. If we click on run, as you can see, the original list contained our original pets, the dog, cat, and bird with size 3. However, the new list, after we added a fourth element, which is the string horse, here we have the dog, cat, bird, and horse, so we have a size of 4. However, we wanted to remove the string cat from our list. So when we print our list after removing the string cat, we have here dog, bird, and horse with size 3. So the string cat no longer exists in our list. Now, what if we want to remove a specific item from the list, but we do not know its value? However, we know its location in the list. For example, the first item in the list or the second item in the list. We can do so by writing pets.pop followed by rounded brackets. And if we leave the brackets empty or blank, we do not write any value inside of the brackets, it will automatically remove the last element or the last item in our list. However, if we specify an index inside of the brackets, for example, if I say 0, here it will remove the item at index 0, which is the first item in our list. Let's actually try it, and we will have here another print statement. And if we click on run, as you can see, the last step we had in our previous scenario, that we removed the value cat or the string cat. So we have dog, bird, and horse with size 3. However, if I say pets.pop and specify the index 0, it will remove the first element in the list, which is dog. Therefore, it will print the new list is bird and horse with size 2. However, if I just copy paste these 2 lines, and this time I do not specify any value inside of the brackets, and I click on run, it will automatically remove the last item in the list. So here, if I click on run, as you can see, the last step we had, that we only have bird and horse with size 2. The list has size 2 because pop-of 0 removed the dog value. However, here, since I have only bird and horse, and I say pets.pop without writing a specific index, it will automatically remove the last item in the list, which is horse. So we will only have bird in our list with size 1. Now, what if we have another list called animals, which contains, for example, turtle as a value and mouse as a second value? So here, this list contains 2 elements or 2 items, the strings turtle and mouse, and we want to actually add them to our pets list. How can we do so? We can simply write pets.extend, and inside of the brackets, we add our new list, which is animals. Here, it will take the values inside of the animals list and add them to the pets list. If we print the pets list, we just copy paste the print statement and we click on the run button. As you can see, the last step we had was the new list is bird with size 1. However, after the extend operation, we now have the new list is bird, turtle, and mouse with size 3. And as you can see, the items of the animals list were added to the end of the pets list. However, what if we want to add a value at a specific location? For example, I want to add a value here at the second position of the list after the value bird. How can we do so? We can write pets dot insert, and here inside of the brackets we will write two values. The first value will be the index. Where do I want to insert my value? And since we are dealing with an index, here, if I want to insert a value at the second position, it will have index 1. Because the first position, as I said before, has the index 0, so the second position will have the index 1. And then we will have the value that we want to insert. So we write the index, comma, followed by the value that we want to insert. And if we want to print our list, we can copy, paste this print statement and click on the run button. And as you can see, this was our last state. Then here it prints the new list is bird and followed by fish because we inserted fish, the value fish, which is the string fish, at position 2, which is index 1. And now let me show you some quick operations we can do while working with lists. One of them is as follows. We can have a new variable called first underscore item, and then we write pets followed by square brackets, and inside of the square brackets we write the value 0. Here we want to access the first item in our list, which is at index 0, and then take a copy of this value and store it inside of our first underscore item variable. Let's print the variable value. Here, for example, we can say the variable value is followed by curly brackets and inside it the variable name, and don't forget to end with double quotations. And also we can print our list and click on the run button. As you can see here, it printed out the variable value is bird because in the previous step, the first item in our list is the string bird. So if I say pets followed by square bracket, and inside of the square bracket we have 0, which is read as pets of 0, here we want to access the first item in the list, which is at index 0. Take a copy and store it in our new variable. And here we are going to print the variable value, which is bird. And then when we print the list again, as you can see, since we only took a copy, we did not remove it from our list. So the first item is still the string bird. So it still exists in our list. What if I do the following operation? Pets.pop of 0. Now, as you can see, here, if you remember the pop operation, it removes a particular value from our list based on the provided index inside of the brackets. Since I provided the pop operation with 0 inside of the brackets, here it will remove the first item in the list from the list. However, after it removes the first item from the list, it will store it inside of the first underscore item variable. So if I click on run, as you can see, it printed out the variable value is bird. However, when I print the list again, I can no longer see the bird value present inside of our list because previously here the first item was bird. The first thing that will get executed is pets.pop of index 0. So here it will remove the first item inside of our list. So now the list no longer has this value and then stores it inside of the first underscore item variable. So here the variable contains bird, however, the list no longer contains bird. And now let's have some other examples. So let's delete everything here. And let's say, for example, we have a list called the numbers, which contains the following numbers 1, 2, and 3. So as I said, a list could have any data type inside it. Here we have integers. For example, we can say floats equal, we could have 2.5, 1.25, and 3.756, for example. We could have a mix of different data types. So here we could call it mixed equal. We could have hello, followed by 1, followed by true, which is a Boolean, followed by example 2.25. And if we print these three variables, if I print numbers and print floats and print mixed, and I click on the run button, as you can see, it printed out the three different lists. The first one, which consists of integers, the second one, which consists of floating point numbers or floats, and here the third one, which is a mix of string, integer, boolean, and a floating point number. And here let me show you a quick hack. Instead of saying numbers equal a list of 1, 2, and 3, we can say numbers equal a list of 1. If I want to create a list with repeated elements, we can use the multiplication operator. So we can say, for example, numbers equal list of 1. So here we only have one item inside of our list, which is the value, integer value 1. If I use the multiplication operator and say multiplied by 5, and I click on the run button, as you can see, it created out a list consisting of 5 ones. Here, it originally began with one item, but since I used multiplied by 5, it will create a list of 5 ones. And we can actually perform this operation on any type of lists. For example, here, if we say pets equal dog multiplied by 3, and here I only print numbers and I print pets and I click on run, as you can see, it created out two lists. The first list contains 5 ones and the second list contains 3 dogs. What if I want to create an empty list? There are two ways to do so. One of them, we could simply say numbers equal, and here we write square brackets, but we leave it empty. We do not write anything inside it. And the other way, here, for example, if we use the pets list, we can say pets equal list, and then followed by rounded brackets. Both will create empty lists. So if I click on run, it printed, as you can see here, empty lists. And then later on in our code, we can add new items to these lists. We can use the append operation and say numbers.append. Here we add the value 1. And then we can say, for example, numbers.insert. We can also use the insert operation, whatever you want to do. But since, for example, I want to insert at a specific location, here at index 0, insert the value 2. Maybe we can do so here, pets.append dog. Then we can say pets.append, for example, cat. But this time, let's try the insert operation. And at index 0, which is the first position in our list, we want to add, for example, bird. And let's print our two lists. Here, if we click on the run button, as you can see, at the beginning, it prints out our empty lists. However, then it prints out our updated lists with the new values. Here, the numbers list with 2 and 1, where 2 is actually at the first position. And then here, this is our pets list with bird as our first item inside of our list because we inserted it at index 0. What if now we want to have some initial values in our lists? Here, for example, in the numbers list, it is easy because we've seen it before. When we use square brackets, we can write anything inside of them. For example, 5, 6, and 7. However, we did not see this notation before when we use the list operation or the list statement, followed by rounded brackets. If I want to insert initial values in this list, I need to write another pair of brackets. And inside of it, we write our initial values. For example, turtle and mouse. And if I click on the run button, as you can see, initially the numbers list had 5, 6, and 7, and the pets list had turtle and mouse. And since we were talking about initializing lists and having empty lists, let's quickly recap how can we initialize variables of different data types in Python. For example, let's delete everything. Here, if I say, for example, pets equal square brackets, this is one way to have an initial empty list, and the variable pets contains this list or points to this list. If I want to have an empty string, for example, a variable called text, and instead of saying, for example, hello, I want to have it as an empty string, nothing inside it. We just write double quotations without anything inside of the double quotations. And if I try to print text, as you can see here, it will just print nothing. It actually printed an empty string, but you could not see anything because it is empty. If you want to, for example, initialize a number, whether it's an integer or a floating point number, usually as a convention, we can say number equals 0. However, there is no other way to do so. But as a convention, we could just say, well, initially the value is 0 because we could not say it's empty. There is nothing called an empty number. We could have an empty list, we could have an empty string, however, we could not have an empty number, whether it is an integer number or a float number. As a convention, we say number equal to 0. And to make sure that our variables, for example, the pets variable, which is a list, it is an empty list, and the text variable, which is a string, and it contains an empty string, we could, for example, print their lengths. For the pets variable, we could use the len operation and say inside it pets. Here, it will print the number of elements or items inside of our list, which should be 0. If I click on run, as you can see, it printed out 0. If we try it on the text variable, the number of characters inside of the text variable is actually 0 because it has an empty string. Nothing is written inside of the double quotations. There are 0 characters. So if I click on run, as you can see, it printed out 0. This time, let's print out the type of each of these variables. Let's have a new print statement. And if you remember, to print out the type of any of the variables, we write type, and inside of the brackets, we write the variable name. Let's write pets, and if we click on run, as you can see, it printed out that it is a list because we initialized it as an empty list. However, if I replace pets here with text, I would expect that it would print str, which is string, and it did. It printed out str. So text, it is an empty string variable. Now, if I replace text with number, as you can see here, it printed out int, which is integer, because we initialized this variable with 0. However, if I initialize it with 0.0, I would expect it to print out float, as you can see, and it printed out float. Now, what if I tell you there is another way to initialize these variables like we did with the list variable? If you recall, there is another way to initialize a list. Instead of using the squared brackets, we could simply write list followed by empty rounded brackets. We could do the same with the remaining variables. For example, for the text variable, which is an empty string, we could either initialize it with an empty string by using empty double quotations, like this example, or we could replace the empty double quotations with str followed by empty brackets, and here this text variable will be initialized with an empty string. We could do the same for the number variable. However, it depends whether we want to initialize it as an integer value or a floating point value. If we rename this variable to int underscore number and we want to initialize it with 0, we could simply write 0, or we could write int followed by empty brackets. Now, if we create another variable called float underscore number and we want to initialize it with 0.0, we could either write 0.0 or we could write float then followed by empty brackets. Finally, if I create a variable called Boolean, I could initialize it by writing bool followed by empty brackets. And here, the default value or the initial value of this Boolean variable will be false. So now let's print these variables, but first let's print their type, and then we are going to print their values. Let's have multiple print statements. Here, for example, we can say the type of pets is, then here inside of the curly brackets, we say type of pets, then we close the double quotations, and then we can copy paste this statement, but change, for example, here we replace pets with text, and here pets with text. Here we say int underscore number, and we replace pets with int underscore number. We can do so for the floating point number variable, here float underscore number, and here we say float underscore number. And finally, we can do it for the Boolean variable. Here the type of the Boolean or the type of Boolean is, and here we replace pets with Boolean. So if I click on run, as you can see, we will have 5 different printing statements. The type of pets is a list, which is correct. The type of text is a string, which is correct. The type of int underscore number is int, which is an integer, therefore it is correct. And the type of float underscore number is float. And finally, the type of Boolean is bool. Now, if we want to print the values inside of these variables to make sure that they are the initial values, we can say, for example, the value here, we will replace the type with the value. Actually, you can copy paste it. And instead of using type, we directly print the variable. So we remove type and we remove its brackets, as you can see. And here, we also remove type. We remove here the brackets and type. So if I click on the run button, as you can see, the value of pets is, and this is an empty list. The value of text is, and since we have an empty string, we cannot see it because it's an empty string. So it actually printed an empty string, but you cannot see it. The value of int underscore number is 0, which is the initial value of an integer variable. The value of float underscore number is 0.0, which is the initial value of a floating point number. And finally, the initial value of a Boolean variable is false. So now let's copy these print statements and let's undo the changes we did. So actually, I want to print their type again, but since I copied the print statements, here, as you can see, I want to print both their values and their types. And here, let's initialize these variables by other values, but using these notations. For example, for the pets list, instead of writing our list using squared brackets, let's try to have some initial values using this list notation. If you recall, I need to write another pair of brackets, and inside of them, I write my list items. For example, dog, comma, cat, comma, for example, fish. Here, if I want to write an initial value, which is not an empty string, I directly inside of the brackets write the string. For example, let's write hello. Here, if I want to have an initial integer value, I directly write it inside of my brackets. For example, 5. The same goes for the floating point number. Inside of the float, I write, for example, 2.5. And here for the Boolean, let's write true. If I click on run, as you can see, here it printed out the value of the pets, which is dog, cat, and fish, the value of the text, which is hello, the value of our integer variable or int underscore number variable, which is 5, and the value of our floating point number variable, which is 2.5, and here the value of our Boolean, which is true. And as you can see, the data types did not change. They are still list, string, integer, float, and bool. As you can see, these notations, which we also call functions, like the list, str, int, float, and bool, their main purpose is not initializing variables. We could use them to initialize variables. However, their main purpose is when we want to do type conversion, which means changing a value from one data type to another. For example, converting a string to an integer or an integer to a floating point number. There are two kinds of type conversion in Python. One of them is the implicit type conversion, where Python automatically converts one data type to another when needed. However, the second type, which is the explicit type conversion or the manual conversion, you convert the type yourself using these functions: the list, str, int, float, and bool. Now, let's see how can we convert the data types from one type to another. For example, for the pets variable, let's remove this input or the initial value, and inside of the list, inside of the brackets, we write the string hello. And let's see the behavior of our program. Also, here, inside of the text variable, instead of initializing it with the string hello, we are going to initialize it with the integer value 3 and see the behavior of Python. Also, for the int underscore number variable, let's input, for example, 5.75, which is a floating point number. And this time, for the float underscore number variable, let's input the integer value 2. And finally, here, for the Boolean variable, let's input the string true. And before we run our code, let me tell you that the concept of type conversion in other programming languages is called typecasting. However, in Python, we refer to it as type conversion. Now, if we click on the run button, we will see the different print statements that we have. The first one is printing the list pets. As you can see, when we input the string hello, here, if I write it inside of the list function or the list notation, it will actually assume that each character inside of this string is a separate element. As we can see here, hello consists of 5 characters. It divided this string into 5 different elements inside of our list. And as also you can see that here we can have duplicate values inside of the list. Here we have the letter L twice. For example, we could have duplicate values in lists. We could have 2 dogs, 3 cats, or whatever. So it is possible to have duplicate values in lists. Now, for the second variable, it says the value of text is 3. And although it says that the value of text is 3, however, if we check the type of text, it is still string and not integer. Therefore, this value, which is 3, is being dealt as if it is a string value, as if we wrote it inside of double quotations. Here, the int underscore number variables, as you can see, it printed out the value of int underscore number is 5, although my input was 5.75. However, since I specified that this is an integer value, it removed everything after the decimal point, as if it extracted the integer part, which is 5, and removed everything else. And also, if you can see the type is integer. So this variable, it has the type int. For the floating point number variable, when we input the integer value 2, here it printed out the value of float underscore number is 2.0, because now it is dealing with it as if it is a floating point number. Therefore, as you can see, the type of this variable is float, and thus it added 0.0 to actually know that this is a floating point number. Finally, here, when we input the string true, for the Boolean variable, it printed out true. However, like we did with the strings, the type here is still bool. It is not string. So the Boolean variable, although I input a string which is true inside of double quotations, however, the type of this variable remains a bool type. However, it's not always possible to change one data type to another. For example, it is possible to change an integer value or a float value to a string. However, it is not possible to convert a string to an integer number or a floating point number. For example, here, if I try to replace 5.75 with the string hello and I click on the run button, it will throw an error because it is not possible to convert a string into an integer value. Also, you could not convert a string into a floating point number. If inside of the float I write the string hello, it will also throw the same error. For example, I could not insert a number directly inside of the list function. So here I inserted the string hello directly inside of the list function. However, for example, if I write here 5, so list of 5 or list of 5.75, it will throw an error because I could not convert an integer value or a floating point value to a list. Now, let's return back this value to the string hello. And if we move on to the bool function, here it is a little bit tricky because whatever you write inside of the double quotations, whatever string you provide to the bool function, it will evaluate the true and store the boolean true inside of the boolean variable. So here, if I say hello inside of the double quotations and I click on run, as you can see, it printed out the value of boolean is true and the type of boolean is bool. So whatever you write inside of double quotations, whatever string you provide to this function, it will evaluate the true, even if I provided the string false. This is the string false. It is surrounded by double quotations. And I click on the run button. As you can see, it printed out the value of boolean is true. The only two ways to have the value of boolean is false are as follows. You either have empty brackets, which is the initial value or the default value, therefore the value of boolean is false, or you actually write false like this, which is the boolean data type way of writing false. You just write false without any quotations or double quotations, and if we click on run, as you can see, it will print out the value of boolean is false. However, if I provide, for example, the integer value 3, it will print out the value of boolean is true. If I provide the floating point number 2.5, it will print out the value of boolean is also true. And since we are done with our type conversion concept, let me show you something interesting in Python. Here in the pets variable, as you can see, we input the string hello into the list function, and the expected output is that it would treat each character or letter in this string as if it is a separate item in the list. As you can see here in the print statement, each letter is treated as if it is a separate item in the list. However, as you can see, each character or letter is surrounded by single quotations. Because in Python, both double quotations and single quotations can be used to create strings. If I replace the double quotations here with single quotations, nothing would change. We would have the same output. As you can see, still each character or letter is treated as if it is a single or a separate item in the list. In this text variable, let's input the string hello, but this time inside of single quotations and not double quotations, like this. And if I click on the run button, as you can see here, the value of text is hello. So we can see that both double quotations and single quotations are used to create or write strings in Python. You could use whatever you want to use. For example, I prefer using double quotations. Someone else would prefer using single quotations. It does not matter in Python. Now, let's move on to a totally different concept, which is as important as the conditional statements concept. First of all, let's remove everything in our code, but let's keep the pets variable and let's actually initialize it with some values. For example, dog string followed by cat string and then the string fish. And what if we print this variable? If I say print pets and click on run, as you can see, it printed out the entire variable, which is the list. However, here it printed out also the squared brackets, and for each item in the list, it printed out the single quotations and also the commas. However, what if I want to print them without the squared brackets, the commas, and the single quotations? If I access each element alone, for example, if I say pets, square bracket, 0, and then click on run, as you can see, it printed out the first item in the list, which is at index 0, the first position, and this item was dog. there are no squared brackets, there are no single or double quotations, there are no commas. What if I want to print all of the items in the list like this? However, a challenge would appear, which is, what if I do not know the size or length of this list? For example, here I know that we only have 3 items. So I could say print pets of 1, followed by print pets of 2. And I click on run. As you can see, it printed out dog, cat, and fish. However, if I do not know the size or the length of my list, how can I use these print statements? Until when will I write these print statements? Here I know that we only have 3 items, so we have an item at index 0, an item at index 1, and an item at index 2. But should I try index 3, index 4, etc.? Or when should I stop? That's the main question if I do not know the size or length of my list. And the answer would be, we can use the loops concept. Loops are used to repeat a block of code multiple times until a condition is met or until you go through all items in a sequence. And a sequence could be a list, a string, a range, for example, as we will see later on. They help you avoid writing the same code over and over again. As you can see, here we wrote the print statement 3 times. And the only thing that changed in these print statements is the index inside of the square brackets. So, to efficiently implement this block of code, we could iterate over or loop over the items in this list until we reach the last item in the list. And for each item, we print it. How can we do so? We can use the for loop. Here, let's delete the print statements. And the for loop is used to iterate over a sequence, and it runs once for each item in the sequence. For example, here, we can write for, and then after the for keyword, we write a temporary variable name. For example, for animal in pets. So here we have 2 keywords. We have for and in, as if I'm saying, for each animal in the pets list, followed by a colon. And as you know, if we use a colon, then we have the next line or the next piece of code is indented 1 tab to the right to indicate that I am in the body of this statement. So as long as there are animals in the pets list, perform the following action as if it is a condition. So it needs to be indented 1 tab to the right. So this code will only get executed if there are animals inside of the pets list or if the condition of this for loop is still true. So as long as the condition is true, I'm going to perform this block of code, which will be print and simply, I would say, animal. Here, if I click on the run button, as you can see, it printed out the 3 items, dog, cat, and fish, each on a separate line without the squared brackets, commas, or single quotations. So here, this is the syntax of the for loop. So we write for, followed by a temporary variable name. For example, we chose to call the variable animal, followed by in, and then followed by the variable name of the list or the list variable name, which is pets. So it will perform the following operation. For each item in this list, assign this item to this temporary variable and then print this temporary variable until you reach the end of the list. Once we reach the end of the list, we exit this for loop and continue the rest of our code. That's why this print statement is indented 1 tab to the right, because it would only get executed if the condition of the for loop is true, which is there are still items in the list. Let's actually have a mixed list. For example, dog, followed by the number 5, which is an integer value, followed by the floating point number 2.75, followed by the Boolean value true. And if I click on run, as you can see here, it printed out dog 5, 2.75, and true. So it can actually work on any data type. Now, let's have a small trick. As you remember, I told you before, we can have any data type inside of a list, including we can have another list inside of this list. So here we have a string, an integer value, a float value, and a Boolean value. What if I say comma, followed by squared brackets, which means I am writing a list having the following values. For example, let's say fish, comma, for example, mouse. Here, if I click on the run button, as you can see, it printed out each item on a different line. However, the last item, it printed out the list which contains fish and mouse, because here, this is an item by itself. And I am looping over the pets list. I'm not looping over the internal lists present in this list. Dog is the first item, 5 is the second item, 2.75 is the third item, true is the fourth item, and this list is the fifth item. So I'm going to print out the fifth item. I do not care what is the type of this item. I'm going to print it. However, since it is a list, as if I'm printing the list, so here it will print fish and mouse in square brackets and single quotations with comma between them. So as you can see, this for loop printed out all of the items present in the list. What if we want to print out the length or the size of the list, which means how many items are present in the list? We can do so by creating a new print statement and saying here, for example, the length of the list is followed by a comma because we are using the old way for printing, and then we say len, and inside of the len we write the variable name, which is pets. If we click on run, as you can see here, it printed out the length of the list is 5 because we have 5 items inside of our list, followed by it printed out the individual items because we still have our for loop here. Now, what if we want to print the fifth item only? We can do so by creating a new print statement, and inside of it, we can use actually the new modern technique for printing. So this time we are going to write F followed by double quotations, and inside of the double quotations, we are going to write the fifth item is, and then we use curly brackets, and inside of the curly brackets, we write pets followed by squared brackets, and then we write the index of the fifth item. Since we want to access the fifth item, the index will be 4, or the index is 4. Here, we write the index inside of the squared brackets, and if I click on the run button, as you can see, it printed out the fifth item, which is a list containing the strings fish and mouse. Now, what if I want to print the first item in this inner list? So here, the fifth item was a list that contains fish and mouse. What if I want to print the value fish, which is the first item in this retrieved or extracted list? How can we do it? There are two ways to do this operation. The first one, we can create a new variable called new underscore list, and we say that this variable is equal to pets followed by squared brackets, and then we write the index of this list, which is 4. So here, when I write pets of 4, it will extract the fifth item in the pets list and put it or store it inside of this new variable, which is called new underscore list. So here, the new underscore list, if we use comments, is equal to fish, comma, mouse. Then we can say first underscore item is equal to new underscore list, and then we will use squared brackets, and inside of the squared brackets we will write the index of the item we want to print. Here, if we want to print the first item, then it has index 0. So if I create a new print statement and say the first item in the new list is, followed by a comma, and then I say first underscore item. So I want to print the value inside of the first underscore item variable. If I click on run, as you can see here, it printed out the first item in the new list is fish, because here we extracted the fifth item in the pets list, which is this inner list that contains fish and mouse, and we stored this value inside of the new underscore list variable. Then we created a new variable called first underscore item, and we extracted the first item from this new underscore list variable, which is the value fish, and we stored it inside of the first underscore item variable. Then we printed out this value. We can do so using another technique. Instead of having two separate lines or two different operations, we could directly write here pets followed by squared brackets 4, then followed by another square brackets and then 0. If I click on run, as you can see, it also printed out the first item in the new list is fish. So actually, these two operations could be performed in one operation like this. We write pets followed by squared brackets, and inside of the squared brackets, we write the index of the item we want to retrieve from the pets list. If we write 4 like this, it means we want to retrieve the fifth item in the list, which is the list that contains fish and mouse. Then followed by another squared brackets, and inside it, we will write the index of the item we want to retrieve from the inner list. So actually here, pets of 4, I retrieved the list fish and mouse. When I say pets of 4, and after I retrieve the list fish and mouse, here I say squared brackets 0, it means get me the first item in this retrieved list. And in this case, it would be the value fish. Therefore, as you can see, it printed out fish. However, it is not a simple task to implement this functionality inside of the for loop, because inside of the body of the for loop, first we need to check on the type of the item. If the type is equal to list, we need to create another for loop, and inside of this for loop, we print the items inside of the inner list. This concept is called nested for loops, and we will discuss it later on. However, for now, let's have another example. For example, let's create a variable called text, and we will assign the string hello to this variable. What if we want to loop over or iterate over the characters or letters of the string and print each character or letter on a separate line? We can create another for loop. We write for followed by a temporary variable name. Let's call it character. And then we write in followed by the sequence variable name. This time our sequence is a string, so we write the text variable name. Then after the colon, inside of the body of the for loop, we write print character. Here, it will print each character on a separate line. If we click on the run button, as you can see, it printed out H, E, L, L, and O, each on a separate line. And as you can see, here we looped over the characters or letters inside of the string. And afterward, we printed out each character. Let's move on to another example. What if we want to loop over a sequence of numbers and print each number? We can do so by writing for followed by the temporary variable name, for example, number. Then we write in, and instead of writing the variable name, we will write range followed by rounded brackets. This is the range function. It could take up to 3 inputs. The first input is the start value, the second input is the stop value, and the third input is the step value. If I write 0, 5, 1, it means that the start value is 0, so the first value we will have is 0. Then the stop value is 5, which means we will have a range of numbers from 0 to 5 minus 1. Here, this stop value, it is exclusive. We will stop at 5 minus 1. This is the last value that we would have. However, the start value is inclusive, so it is included in our range. And then we have the step value is 1, which means incrementing by step. so I would increment by 1. If I write my colon and then inside of the for loop body, I say print number and I click on run, as you can see here, it printed the numbers from 0 to 4 inclusive because my step is 1, so 0, 1, 2, 3, and 4. However, since my stop value is 5, so I stopped at 4 because I stopped at 5 minus 1 or stop minus 1. So my last value is 4. What if we change our step value to 2 and I click on run? As you can see, it printed out only 0, 2, and 4 because it increments the value by 2. So 0 plus 2 is 2, 2 plus 2 is 4, and then we reach the end because 4 plus 2 is 6, which is outside of our range. Because here, our stop value is 5, so we can stop at 5 minus 1, which is 4. Let's actually change our stop value. Let's stop, for example, at 7. If I click on run, as you can see here, we also have a new value, which is 6, because 4 plus 2 is 6, which is still less than 7. So it is printed. However, 6 plus 2 is 8, which is outside of our range, because the last value we could have is 7 minus 1, which is 6. We could actually have another start value. For example, 1 instead of 0. And let's have our step value as 1. And let's here have our stop value as 5. As you can see, it printed out 1, 2, 3, and 4. Because my step value is 1, so it increments by 1. My start value is 1, so I started with 1. And then 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. However, my stop value is 5. So I could not print out 5 because it is not included in my range. Because here the stop value is 5, so 5 minus 1 is 4. 4 is the last value that could be included in my range. If you remember, few moments ago, I told you that the range function could take up to 3 inputs. So I did not say it takes 3 inputs exactly. I said it can take up to 3 inputs. Because if I only write 5 inside of the rounded brackets and I click on run, it would generate all numbers from 0 to stop minus 1, which is 5 minus 1, which is 4, with an increment step of 1. So here it printed out 0, 1, 2, 3, and 4. If I provide the range function with 2 inputs, for example, 0, 5, and I click on run, here it would generate all numbers from start, which is 0, to stop minus 1, which is 5 minus 1, which is 4, like this. So let's say, for example, let's have a different start, which is 1. As you can see, here it generated all numbers from 1 to 4, which is stop minus 1, with an increment step of 1. If we only have one input, it would be the stop value. If we have 2 inputs, it would be the start and the stop value. If we have 3 inputs, it would be the start, then the stop, then the step values. However, it is important to note that the output of this range function is not a list of numbers. Rather, in Python, there is a data type called range, and the result of this range function is of type range. If we create a variable called numbers underscore range equal range of start value 0 inclusive, stop value 5 exclusive, and a step size of 1, and if we replace this range function with our variable's name, we say numbers underscore range, and we click on run, as you can see, it printed out the values from 0 to 4 inclusive with a step size of 1, which means each value is incremented by 1. Now, if we print outside of the for loop the value of the numbers underscore range variable and its type, for example, let's say the variable's value is followed by numbers underscore range, the variable name, and let's print here its type. The variable's type is followed by type of numbers underscore range. If I click on run, as you can see, the variable's value is, it printed out a range of 0 to 5, and the variable's type is, as you can see, it printed out that it has the type range and not a list. So here, if I create a new variable called numbers underscore list equal, and if I initialize a list, for example, 0, 1, 2, 3, 4, which would have the same behavior as the previous variable. Here, if I replace this variable with numbers underscore list, and let's comment these two print statements for now. If I click on run, as you can see, it also printed the values 0 to 4 inclusive with a step size of 1. However, here, let's uncomment these print statements, and let's say the numbers underscore range value is, and here the numbers underscore range type is, and let's copy paste these two print statements, and this time we say the numbers underscore list value is numbers underscore list, and here the numbers underscore list type is, and inside of the type function we say numbers underscore list. Run. Here, as you can see, this time the numbers underscore list value is a list of integers and its type is list. So it's not a range, it's a list. And that's why when we use range, it creates a variable of type range. However, here, when we use the list, it creates a variable of type list. Now, what if we replace the step size? Instead of writing 1, we want a step size of 2. And if we click on run, we will see here that the numbers range value is a range with start value 0 inclusive with stop value 5 exclusive, and here it added the step size, which is 2. So previously we did not have the step size being printed because by default the step size is 1. However, if I explicitly specify a step size, here Python will print the step size if it is not equal to 1. Now, let's move on to a totally different problem. This time, I'm going to have a variable called numbers underscore list. And here I'm going to create a random list of numbers. For example, 20, 11, 5, 2, and 4. And I want to print only the even numbers present in this list. I do not want to print everything. I want to only print the even numbers and not the even and the odd numbers together. Here, the even numbers are 20, 2, and 4, while the odd numbers are 11 and 5. How can we print only the even numbers? We need to loop over this list. So we are going to create a for loop saying for number in numbers underscore list. Then inside of the body of this for loop, we need to write a condition. We need to check on each number in this list whether it is even or odd. How can we perform such check? Actually, if you remember, all even numbers are divisible by 2. So any even number in the universe is divisible by 2. How can we check whether this number is divisible by 2 or not? If you recall the remainder operator, where it actually calculates the remainder of the division operation, if all the even numbers are divisible by 2, this means that the remainder is 0. There is no remainder. So we can perform this check. And we could say here, if the number modulus 2 is equal to 0, so number modulus 2, it will calculate the remainder operation. If the output or the result is equal to 0, it means that this number is divisible by 2. Therefore, here we have a colon, and we move on to the body of the if statement, and we print the number. So as you can see, this if statement is one tap to the right with reference to this for statement, because this is inside of the for statement body. However, this print statement is 2 taps to the right from the for statement and 1 tap to the right from the if statement, because this print statement is in the body of the if condition. If the if condition is true, I'm going to execute this print statement. Otherwise, if it is false, I'm not going to execute this print statement. And let's click on run. And as you can see, it printed out the even numbers, 22 and 4. What if we want to print the odd numbers and not the even numbers? It is simple. Here, instead of checking that the result of the remainder operation is equal to 0, I'm going to check whether it is not equal to 0. Because if it is not equal to 0, it means that this number is not divisible by 2. Therefore, it is an odd number. And if we click on the run button, as you can see, here it printed out 11 and 5, which are the odd numbers. Now, what if I want to only print the first odd number in this list and then quit my program? How can we do it? Here, I'm going to check normally whether it is not divisible by 2. If it is not divisible by 2, which means that the remainder operation, the result of the remainder operation is not equal to 0, I'm going to print the number. Then I'm going to write the following keyword, which is break. Here, when I click on run, as you can see the output, it only printed 11. It did not print 11 and 5, because what happened is, at first, for each number in the list, we are going to check whether this number, the remainder operation, is not equal to 0. The first item in our list is 20. 20 modulus 2 is actually equal to 0. Therefore, I will not execute this if statement or the body of the if statement, and then I will return back to my for loop. For the second item in the list, which is 11, I'm going to check, is 11 modulus 2 not equal to 0? Yes, 11 modulus 2 is equal to 1, so it is not equal to 0. Therefore, I'm going to execute the body of the for loop. Here, I'm going to print 11, then I'm going to execute this break statement. And this break statement tells Python, break from this for loop. Exit the for loop immediately. Do not continue. Therefore, it will execute the break statement, and then it will continue the rest of the code outside of the for loop. Here, for example, if we have a print statement saying hello, if I click on run, it will print 11, then it will break from the loop, it will exit the loop, and continue the remaining of the program, which is printing hello. And now, let's modify this scenario. Instead of printing out the number, which is an odd number, and then breaking out from this loop, or breaking from this loop, I will create another variable called pets, which is a list of strings. Contains, for example, dog, cat, and bird. And instead of printing the number from the numbers underscore list, if the number is an odd number, I want to print all of the items in the pets list, each on a separate or new line, and then I break from the for loop. How can we do so? Here, I'm going to add a space for readability. Since for number in numbers underscore list, I'm looping over the numbers underscore list, which is a list of integers, and I'm checking on each item. If the number modulus 2 is not equal to 0, which means it is an odd number, instead of printing out this number, I'm going to write another for loop. And here comes the concept of nested for loops. Here we have an outer for loop and an inner for loop. I will say for animal in pets, print the animal variable. And now let's check our indentations. Here we have the outer for loop. Inside of its body, we have this if condition. Therefore, this if condition is one tab to the right, because this is inside of the body of the outer for loop. Then, if the condition is true, I'm going to execute the body of the if condition, which is the then part. Here inside of the if condition, we have this for loop. As you can see, this for loop is one tab to the right with reference to the if condition, because this is inside of the body of the if condition. However, it is two tabs to the right with reference to the outer for loop. Here, as you can see, this inner for loop, we are going to loop over the pets list, and inside of the body of this for loop, I'm going to print the items of this list. Therefore, this print statement is one tab to the right with reference to the inner for loop, because this is inside of the body of the inner for loop. However, it is two tabs to the right with reference to the if condition, and three tabs to the right with reference to the outer for loop. After I finish printing all of the animals, I will exit this for loop, and as you can see, we have this break statement which is on the same indentation level as the for or the inner for loop, because this is inside the body of the if condition. I will perform the for loop, I will print all of the items inside of the for loop, and when I'm done, I go back and continue the body of the if condition, and here I have break, and then I will break from my outer loop. This break is one tab to the right with reference to the if condition because it's inside its body. However, it is two tabs to the right from or with reference to the outer for loop. So let's click on the run button and see the output. As you can see, it printed out dog, cat, bird, and then hello. Let's trace our code. For number in numbers underscore list, we are going to take the first item, which is 20, and then we check if 20 modulus 2 is not equal to 0. No, this condition is false, because actually 20 modulus 2 is equal to 0. So I will not execute the body of the if condition, which is the highlighted part, and then I will return back to the for loop and move on to the next item, which is 11. If 11 modulus 2 not equal to 0, yes, 11 modulus 2 is not actually equal to 0 because it is equal to 1. Therefore, we are going to execute the body of the if condition. Here we have an inner for loop. So for animal in pets, we are going to loop over the items in the pets list. The first item is dog, so I'm going to print dog. Then I return back to the for loop. The second item is cat. I'm going to print cat. Then I go back to the for loop. The third item is bird. I'm going to print the third item, which is bird. And when I go back to the for loop, I can no longer find any items. So I exit this for loop, and then I see the break statement. Here, I need to break from the outer for loop. That's why it only printed dog, cat, and bird once, because now it breaks from the outer for loop, and then it prints this hello, which is outside of the outer for loop. So when it breaks from the outer for loop, or it exits the outer for loop, it will continue the remaining code that is outside of the outer for loop, which is here this print statement. However, this break statement may be confusing to some people. So what if we move it one tab to the right, and now it is inside of the body of the inner for loop? Let's see the behavior of our code if we click on run. As you can see, it printed out dog, then it printed out another dog, followed by hello. If we trace our code, starting with the first number, which is 20, if we perform this if condition, it is false, so we will not execute the body of this if condition. Then we return back to the outer for loop. The second item is 11, and as we said before, this condition is true when the number is 11, because 11 modulus 2 is actually 1, so it is not equal to 0. Then here, when we execute this inner for loop, we will start with the first animal, which is dog. We will print dog, and then we will execute the break statement. This break statement will only break from the inner for loop and not both loops or the outer for loop. Since this break statement is actually in the scope of the inner for loop, it is one indentation to the right from this for loop. Therefore, it is inside of the body of this for loop. So when I execute this break statement, it tries to break from the closest for loop it can see within its scope, which is the inner for loop. Python printed out the first item in the pets list, which is dog. Then it executed this break statement, which actually breaks from the inner for loop, and we return back to the outer for loop. The third item in the list, which is the integer value 5, if number modulus 2, which is 5 modulus 2, not equal to 0, actually 5 modulus 2 is equal to 1. Therefore, this condition is true, and we are going to execute the inner loop again. We print the first item in the pets list, which is dog, and then we break again. Therefore, here we have the second dog being printed in the terminal, and then we break from the inner for loop, we return back to the outer for loop, and the next item is 2. 2 modulus 2 is actually equal to 0, so this condition is false. We do not execute the body of the if condition and return back to the outer for loop. The last item in our list is 4. 4 modulus 2 is actually equal to 0, so also this if condition will evaluate to false. We will not execute its body, and we return back to the for loop or the outer for loop, where we have no longer any items in our list. So we do not do anything. We exit this outer loop and continue the rest of our code, which prints hello. And if you remember at the beginning of the loops section, when we had the variable mixed, which was a list that contained values of different data types. For example, it contained the string dog, the integer value 5, the float value 2.75, the Boolean value true, and also it contained an inner list like this, which contained the values fish and mouse. So here, this mixed list contains 5 items, a string, an integer, a float, a Boolean, and an inner list or another list. And if we wanted to print the individual items inside of the inner list, I told you we need to check on the type of the items inside of the bigger list or the mixed list. And if the type was list, we will actually create a nested for loop and print the individual items inside of the inner list. So let's implement this scenario. Here, we are going to have a brand new for loop. We say for item in mixed. Here, I'm looping over the items in the mixed list. Then I'm going to check on the type of each item. I can say if type of item followed by is list, and as you can see, I could either use rounded brackets to actually indicate that this is the condition of the if statement, or we could remove the rounded brackets. Both can work normally. However, since we usually use the rounded brackets for a change, let's not use them now. Here I'm checking if the type of this item is list, perform the following operation. Inside of the if statement, inside its body, if the condition is true, I'm going to create another for loop for animal in item, and then I would say print the animal. And for simplicity, we only want to print the individual items of the inner lists present in this mixed list. I do not want to print the other values for simplicity. Here, if I click on run, as you can see, it printed out fish and mouse, each on a separate line. Because if we trace our code for each item in mixed, here, for example, the first item is the string dog. If the type of this item is list, we perform the following operation. However, the type of dog or the type of the first item is a string. So I do not execute the body of the if statement. And then I return back to the for loop, checking on the second item, which is the integer value 5. The type of the second item is not a list. So I go back to the for loop. I check on the third item. The type of the third item, 2.75, is float and not a list. So I go back to the for loop. And then I check on the fourth item. The type of the fourth item is a bool. It's a Boolean value. So I do not execute the body of the if condition because the condition is false. It is not a list. Then I move to this fifth item. When I check the type of the fifth item, is it a list? Yes, this condition evaluates to true. Therefore, we go to the body of the if condition, and as you can see, we have a nested for loop. Here, we loop over the items inside of this inner list. So for animal in item, the first item in the inner list is fish, so it's going to print fish. Then the second item is mouse, so it is going to print mouse. What if we change the first item in the mixed list into another inner list, and this time it contains two strings, dog and cat, like this? If we click on the run button, as you can see, it printed out dog, cat, fish, and mouse, because the first item in our mixed list is now another list. It's a list. So this condition will evaluate the true, and then for each animal in this list, or for each item in the inner list, the first item is the string dog, so it will print the string dog, and the second item is the string cat, so it will print the string cat. However, for this if condition, Python recommends using another check instead of using the type of item is list. Python recommends using the following function, which is called isInstance. So we are going to write if isInstance, then inside of the rounded brackets, we write our variable, which is item, followed by the type that we want to check on, which is list. If we click on run, as you can see, it would print out the same output, dog, cat, fish, and mouse. However, Python recommends using the isInstance function. So here I'm checking whether this item is an instance of the list data type. If it's true, which means the item is actually a list, it would execute the body of the if statement. Now, what if we want to print all of the values inside of the mixed list? We could simply write an else part to this if condition, as we've seen before, and inside of the else body, we will say, for example, print the item. And if we click on run, as you can see, it printed out dog, cat, 5, 2.75, true, fish, and mouse. And it did not print the list dog, cat, and the list fish, mouse, because the print item is in the else part of this if condition. So if the item is not a list, I'm going to execute the body of the else part, which is printing the item. So either I print the individual items if the item is a list, or I print the item itself if the item is not a list and it is another data type, like a string, an integer, or whatever. And actually, inside of the brackets of the isInstance function, here we are comparing the type of the variable item, whether it is a list or not. However, we could replace list with other data types. For example, if I want to compare the type and see whether it is an integer or not, I can write int. If I want to compare it to a floating point number, here I write float. If I want to compare the type to a string data type, I could write str. If I want to compare the type to a Boolean data type, I could write bool, and so on. And also we can do this if we use the old way, which is saying, for example, if type of item is list, we could replace also here the list with int, for example, or float, and so on. Now we are done with for loops. Let's move on to the second type of loops, which is the while loop. The for loop, as you can see, it is used when you know in advance how many times you want to repeat something or a specific piece of code. So as you can see here, it iterates over or loops over a sequence like a list, a string, or even a range. However, while loops are used when you do not know exactly how many times your code should run. It keeps running as long as a condition is true. So now let's have an example where the while loop is a better option than the for loop, meaning that we do not know exactly how many times should we iterate or loop until we exit our loop block. Let's create a variable called correct_password and assign it the following string, Python123. And here we will ask the user to enter their password. As long as the password is incorrect, we will re-ask them to enter the password again. So here, let's have another variable called input_password password, which will be a string input from the user. Enter your password, and then let's create our while condition. To write our while loop, we basically write while followed by the condition, which is input underscore password is not equal to correct underscore password, followed by a colon. And as you've seen before, we could either put this condition inside of rounded brackets or not, as you like. For example, let's keep it inside of rounded brackets. Here, we are going to loop as long as the input password is not equal to the correct password. Inside of the while loop body, we are going to re-ask the user again to input their password. So we are going to say input underscore password is equal to this string input, which is enter your password. And then outside of the while loop, we are going to print access granted. So let's trace this code. Here, at first, we initialized the correct password with the following string, Python123, and then we are going to ask the user to enter a password. Here we have the while loop condition. As long as the input password is not equal to the correct password, I'm going to enter and execute the body of the while loop. Inside of the body of the while loop and take care of the indentation, it is one tab to the right indented because it is inside of the while loop. It will only get executed if the condition of the while loop is true. Here, we are going to ask the user to enter their password again in the same variable, which is input underscore password, because this is the variable that we're checking on inside of the while loop condition. And then if the user enters the password correctly, we are going to exit the while loop because this condition will no longer be true and it will be false, and we are going to print access granted. So if we click on the run button, as you can see, it will ask us to enter your password. If I enter Python12, it will ask us again to enter your password. If I enter Python13, it says enter your password. This time, if I say Python123, it printed out access granted. Let's trace this code. At the beginning, the very first time, which is this statement, it asked us to enter the password. If I enter Python12 as the password, here, when we try to execute this while loop and check on the condition, is Python12 not equal to the string Python123? Yes, this condition is true because Python12 is not equal to the string Python123. So we are going to execute the body of this while loop. And here it asks us again to enter the password, which is the second time it asked us to enter the password. If I enter Python13, then we go back to the while loop and it checks, is Python13 not equal to the string Python123? Yes, this condition is true. Therefore, we enter the body of the while loop again. And this time it will ask us enter your password, which is this third time that it asked us to enter the password. Here, if I enter Python123 and I return back to the while loop condition, is Python123 not equal to Python123? No, this condition is false because actually Python123 is equal to Python123. So we will not execute the body of this while loop and we directly exit the while loop and go to printing access granted. As you can see, as long as the condition of the while loop is true, we are going to execute the body of the while loop. However, once the condition is false, we are going to exit the while loop and continue the rest of our code. So here we use while loops when we do not know exactly how many times we are going to loop, unlike the for loops where we know exactly how many times we are going to loop. For example, we use for loops when we want to loop over a list of items. We know exactly how many items are present in the list. Let's try another example. If we click on run and we input the correct password directly, here it printed out access granted because we are going to check is Python123 not equal to Python123. This condition is false because actually Python123 is equal to Python123. So we are not going to execute the body of this while loop, and then we are going to print directly access granted. However, if I try and inputting the following value, Python 1, 2, here Python 1, 2 is not equal to Python 1 to 3. So we are going to execute the body of the while loop, and that's why it asked us to enter our password again. If I enter the password correctly, here it printed out access granted because once I enter the password, it will return back and check on the condition. Is Python 1 to 3 not equal to Python 1 to 3? This condition is false because they are actually equal. So I'm not going to have another iteration, and I will exit the while loop and print access granted. Now, let me show you an interesting thing when dealing with loops. Let's have the following example. Here we have a variable called pets, which is a list of strings like dog, cat, and bird. And if you wanted to print out the items inside of this list, the better option is using a for loop and not a while loop, because simply we can write for animal in pets print animal. And if we click on the run button, as you can see, it printed out the 3 items present in the list. Now, the challenge is, can you implement this functionality but in a while loop instead of a for loop? The answer is yes. We can implement it using a while loop. However, the efficient way to do so is using for loops. Still, however, we can implement it using a while loop. To implement this example using a while loop, we need to do the following things. Number one, we need to create a variable called counter, and we initialize it with 0. Then we are going to say while the counter is less than the length of my pets list. So here I'm checking. As long as the counter value is less than the length of the pets list, which is the number of items present in the pets list, do the following operation. Print, and this time we are going to say pets of counter. So instead of specifying an exact index, we here can put a variable. However, of course, this variable should be of type int, because Python will retrieve the integer value inside of the variable, and this will be the index of the list, and then we will access this specific item at this index and print it. However, I'm going to do the following. Then I'm going to say counter equal counter plus 1. Or, as we've seen before, I could simply say counter plus equal 1, which is counter equal counter plus 1. Both ways are correct. But for simplicity, let's write it like this, counter plus 1. And let's comment the for loop and let's run our code. If we click on the run button, as you can see, it also printed out dog, cat, and bird. Let's trace our code and see why did Python print these values. As you can see, we initialized the counter variable with 0. Then we are going to check on the condition of the while loop. Is the counter variable less than the length of the pets list? Here, the counter variable contains the value 0, and the length of our pets list is 3 because it contains 3 items. 0 is less than 3. Therefore, I'm going to execute the body of the while loop, which contains 2 statements. The first statement is a print statement, which prints the value of pets of counter. Here, counter contains the value 0. So, pets of counter is the first item in the list, which is the string dog. So, it will print the string dog, and then in the second statement, it will increment the counter by 1. It increased its value by 1. Therefore, now we return back to the while condition. Is the counter, which now contains the value 1, less than 3, which is the length of our pets list? Yes, this condition is true. Therefore, we are going to execute the body of the while loop, and we are going to print pets of 1, which is the second item in our list, which is the string cat, and then we are going to increment our counter again by 1. So we printed cat, we incremented the counter by 1, now it contains the value 2. We return back to the while condition, 2 is less than 3, therefore we are going to execute again the body of our while loop. We are going to print pets of 2, which is the third item in our list, which is the string bird. As you can see, it printed out bird, then it increments the counter by 1. 2 plus 1 is 3. Now we are going to check, is 3 less than 3? No, this condition is false, therefore it will no longer enter the while loop body and it will exit this loop. So as you can see, if we wanted to implement this functionality using a while loop, we had to write more lines of code. We had to write 4 lines of code. Here we initialized the counter variable. Here we wrote the while condition. Here we printed the item from the list. And here we incremented the counter by 1. Compared to if we wanted to implement this functionality using for loops, we only had to write 2 lines of code. For animal and pets, print animal. So it's more efficient to use for loops compared to while loops if we want to loop over or iterate over a sequence like a list, a string, or a range of numbers. And since here we already have a variable, which is a list, let me show you some quick hacks regarding printing this variable. Let's first comment the following statements. And if you recall, if I wanted to print the variable, I simply write print and then pets. And if I click on the run button, as you can see, it printed out the variable, which is a list. So here we have the squared brackets, we have single quotations and commas, and the values of this list, which are dog, cat, and bird. What if I want to print a subset of this list? For example, I want to print only the first 2 items. I could say, instead of saying print pets, after pets, I would write here squared brackets, and then I would say colon, and then this is the dog is at index 0, the cat is at index 1. So I say colon 2. And if I click on the run button, as you can see, it only printed out dog and cat. Because here, this tells Python that print everything from the beginning until this index exclusive. So here we will print the item at index 0, the item at index 1. However, we will not print the item at index 2 because this value is exclusive. And there is another way to do so. If we write 0 before the colon and then click on the run button, as you can see, it printed out the first 2 items in the list. However, they are of type list. Therefore, we have the squared brackets, the single quotations, and the comma. Here, the value before the colon is the start index inclusive. Therefore, if I write 0, it will start accessing from index 0. However, if I leave it blank, automatically it will start accessing the item at index 0. However, the value after the colon is the stop index exclusive. So here, if I write 2, it will not access the value at index 2. The last value that would be accessed is at index 1 because this value is exclusive. It is not included. Okay? So let's, for example, say from 1 to 3, and we click on run. As you can see, it printed out cat and bird this time because cat is at index 1, which is the start index inclusive, and bird is at index 2. However, since my end index or my stop index is 3, so I stopped. I did not continue because actually this list does not contain an item at index 3 anyways. However, just to understand that this value, which is 3, it is exclusive. So it will not access this value. So, for example, if we add here fish and we click on run, as you can see, it only printed cat and bird, index 1 and index 2. Now, let's do some operations on this list for your general knowledge. Let's delete the loop statements, and here let's return this back to printing the list pets. And if I click on run, as you can see, it printed out the list with its 4 items. What if I want to delete or remove all of the items inside this list? I could simply say here pets.clear followed by empty brackets. And if I try to print the pets list and click on run, as you can see, initially it printed the list with its items, which is this printing statement on line 4. However, when I called .clear on the pets list, it removed everything inside of the list. And when I printed the list again, as you can see, it printed out an empty list. So as you can see, here when we called .clear on the pets list, it removed everything from this list. Now we have an empty list. Therefore, when we printed this variable again, as you can see, it printed out an empty list containing 0 items or elements. Now, let's move on to another operation that we can perform on lists. Let's create a new list called numbers, which will contain integer values. For example, 3, 1, 4, 5, and 2. And as you can see, this list is not ordered or sorted. So the numbers are in random positions. If I print this list, as you can see here, it will print exactly what I initialized. This list containing 3, 1, 4, 5, and 2, which are integer values. What if I want to order or sort this list? There are 2 ways to do so. The first way is that you implement a sorting algorithm using, for example, loops, or we use the built-in sort function. So if we write numbers.sort followed by empty brackets, this function, which is called the sort function, will order or sort the items inside of the list ascendingly. So from the smaller value to the bigger value. Here, if I print my variable again and I click on the run button, as you can see, it printed out the correct or sorted list. Here, initially, it printed out the original list, which was not ordered or sorted. Then after we called .sort on the variable, which is the numbers variable, here it sorted our items inside of the list ascendingly. As you can see, it printed out 1, 2, 3, 4, and 5. What if we want to sort this list descendingly? So from the bigger value to the smaller value. Actually, this sort function can take up to 2 inputs. One of them is called the reverse input, and initially it is false. If I say reverse equal true, then here it will reverse the sorting mechanism. And instead of actually sorting from the smaller value to the bigger value, it will sort from the bigger value to the smaller value. So here, if I say numbers.sort, and inside of the brackets, I write reverse equal true, and then I print my numbers list and click on the run button. As you can see here, it printed out the list in descending order. So it sorted it descendingly. As you can see, it printed out 5, 4, 3, 2, and 1. Because here we specified that the input or actually the argument. So if a function is taking inputs, we call these inputs arguments. And here, one of the arguments is called reverse. So if I say reverse equal true, this means that, well, I want to reverse the sorting mechanism. What happens if we have negative numbers inside of our list? For example, we add -4 and -2 instead of 4 and 2. So we add a negative sign before them. And let's comment this part of the code and just print out the list as it is. As you can see, the list is printed normally. What if we uncomment the .sort function and then we print the list again. Here, it will sort the list ascendingly. So we expect that the lowest value would be -4, followed by -2, and then 1, 3, 5. If we do the other way around, which is sorting it descendingly, and then we print the list, and we click on the run button, as you can see, it printed out the values in descending order. So 5, 3, 1, -2, and -4. So now the list is sorted descendingly. What if I want to actually sort the list based on another function or another factor? For example, I want to list it ascendingly, however, based on the absolute values inside of the list. Meaning, if I have -4, I want to deal with it as if it is 4. If I have -2, I want to deal with it as if it is 2. This is the absolute values. For example, let me show you. Here, if I say print, and then inside of the brackets, I write ABS, which stands for absolute, and inside of the brackets, I write -4, and I click on the run button. As you can see, it printed out 4, because the absolute value of -4 is 4. The absolute value of -2 is actually 2. The absolute value of -9 is definitely 9. So here, what if I want to order or sort this list, however, based on the absolute values of the items inside of the list, not based on their sign, whether they are positive or negative. Here, we can actually change the function of the sort. So if we delete this print statement and we uncomment the first two statements, here we are going to print the list. Then we want to sort it based on the absolute value of the items inside of the list. Here, there is a second input or a second argument we can provide to the sort function, which is called key. So if I say key equal to, and then I specify on what basis or what function do I want this sort function to employ or to use when sorting the list. Here we want to sort it based on the absolute value. So if I say key equal ABS, which is absolute, this will sort the list based on the absolute values. So if I uncomment this statement and I click on run, as you can see here, it printed out 1, -2, 3, -4, and 5, which is ignoring the negative sign. It is 1, 2, 3, 4, 5. So therefore, the sorting function or the sort function actually sorted or ordered the list based on the absolute values of the items, regardless of their sign, when we specify key equal ABS or absolute. Thus, for now, we have two arguments for the sort function. The first one is the key, and the second one is the reverse. So here, what if I want to actually sort it based on the absolute value, however, descendingly and not ascendingly? So if I uncomment this line and write here key equal ABS, comma, reverse equal true, and then I uncomment this print statement and I click on the run button, as you can see, it printed out 5, -4, 3, -2, and 1, which means now the list is sorted descendingly, and the sorting function is the absolute value of the items inside of this list. And as you can see here, key equal ABS, ABS is the function name in Python. If you remember when I wrote ABS -4 inside of the print statement, this is the same ABS. It will call this function on the items of the list to actually determine their absolute value and then sort it ascendingly or descendingly based on the reverse argument. Now, what if we have a list of strings? For example, let's here create a new list called pets equal turtle, followed by dog, followed by horse, then followed by bird. And I want to sort this list. If I say print pets and I click on the run button, it will print the list as it is. However, if I say pets.sort and we do not provide any argument, then we say print pets and we click on the run button. What do you observe? As you can see, here it sorted the strings alphabetically. So here bird, it starts with a B, that's why it's the first item. Dog, it starts with a D, therefore it is the second item. Horse, it starts with an H, therefore it is the third item. And finally turtle, which starts with a T, therefore it is the fourth item. So as you can see, when we did not provide any arguments to the sort function, it automatically sorted the list alphabetically based on the alphabetical order of the strings present inside of the list. What if I want to sort this list based on the size or length of the strings present in the list? For example, bird has a size or length of 4 because it has 4 characters. Dog has a size or length of 3 because it has 3 characters. Horse has a size or length of 5 because it has 5 characters. And turtle has a size or length of 6 because it has 6 characters. Here we are going to write pets.sort, and if you remember from the previous example, we are going to write key equal and then provide the function that we want the sorting to be based on. Here we want the sorting to be based on the length or the size of the strings, therefore we are going to use the len function, and then we are going to print our list. So if we click on the run button, as you can see, it printed out the list. However, now it is sorted based on the length or the size of the items present in the list. Dog has the smallest size of 3, while turtle has the biggest size of 6. And then here, after dog comes bird, which has a size of 4, and horse, which has a size of 5. So we're as if it is ordering or sorting based on size 3, size 4, size 5, and size 6. This is ordered ascendingly. What if we want to actually sort this list based on the size or length of the strings, however, in descending order? Simple. We are going to say pets.sort key equal len, and then we are going to say reverse equal true. If we print pets and we click on the run button, as you can see, it printed out turtle, followed by horse, followed by bird, followed by dog, with turtle having the most characters, 6 characters, and dog having the least number of characters, which is 3 characters. So here, the list was sorted based on the length of the strings inside of the list, however, in descending order. Let's move on to another example, and let's create a new variable called students, which is a list of strings. However, this time it will contain names. For example, Alice, Bob, and Eve. Here we have 3 strings, each represents a student name, and they are stored inside of a list, and the variable that stores this list is called students. What if for each item or for each student, I want to store their student ID together with their name? How can we do so? There are multiple ways to do so. One of them is using a new data type, which is called tuples. Tuples in Python are like lists. However, they are immutable, which means they cannot be changed after creation. And we write them using parentheses or brackets. We do not write them using the square brackets technique. So first, let's print our students list like this and click on the run button, as you can see. Then let's reinitialize the students variable. Here, we will use normal squared brackets because we will have a list containing students. However, for each item inside of this list, it will be of type tuple and not of type string. How can we actually write a tuple? We are going to use brackets or parentheses, and then inside of the brackets, we are going to write first the student ID, for example, 1, 2, 3, 4, followed by a comma, followed by the student name, which is Alice. So here we have the integer value, which is the student ID, comma, the student name. And then after the brackets or parentheses, we write another comma, because now we are done with the first item in our list. We write, for example, the following student, which will have ID 1235, comma, here we write Bob, and then after the parentheses or brackets, we write another comma followed by another pair of brackets or parentheses, and then we say 1236 as the student ID followed by the student name, which is Eve. So if we print students again and we click on the run button, as you can see here, it printed out the list and each item is a tuple. Here, the first item is a tuple containing the value 1, 2, 3, 4 and the value Alice. Here, the second item is a tuple containing the value 1, 2, 3, 5 and the value Bob. Finally, the third item in our list contains a tuple which has the value 1, 2, 3, 6 and the value Eve. And actually, we could have multiple values inside of a tuple. So not only two values, which are the ID and the name. We could have, for example, here, the gender. Let's F. And here, comma, for example, M. And here, comma, F. And if we click on run, as you can see here, it printed out the first item, which contains an ID, the name, and the gender. Here, the second item contains the ID, the name, and the gender, and so on. So a tuple could actually have more than one value, more than two values. It could have any number of values you want. So basically, it depends on the information you want to store together as one item in our list. Now, what if we want to access these tuples? If I say first underscore student equal students of 0, here I will access the first item in the list, which is actually the first tuple that contains 1, 2, 3, 4, Alice and F. If I say first underscore student underscore ID equal first underscore student of 0, and then I decide to print first underscore student underscore ID, and I click on the run button, as you can see here, it printed out the value 1, 2, 3, 4, which is the ID of the first student. So actually here we first access the first tuple by saying students followed by squared brackets of 0, which here accesses the first item in our list. It retrieved this tuple, the first item. So here, if I say print first underscore student and I click on run, as you can see, it extracted the first item, which is the first tuple. And then using the same way as we access lists, we accessed the first tuple. Here, the first item in the first tuple is the student ID. So when I say first underscore student followed by squared brackets of 0, it will extract the ID and then we printed out the ID. We can say, for example, print first underscore student of 1, and here it will print the name. As you can see, it printed out Alice. What if we say first underscore student of 2, here it will print the gender, which is F or female. And if we want to print the size or the length of this tuple, we can simply create a new print statement, and inside of it we write len, which is our length function, followed by the tuple name. Or here, for example, it is stored inside of the first underscore student variable. So here, if I say len of first underscore student, it should print out 3, because here, yes, it printed out 3 because this tuple contains 3 items. However, as you can see, tuples are not a good way to represent this combination of student and their information, because you need to actually know the order of the items. Here, I knew that the first item is the student ID, the second item is the student name, and the third item is the student gender. However, if I do not know the order of the items, it will be a problem, because, for example, if I want to access the student name, but I do not know its location inside of the tuple, how can I use the index? I do not even know its index. Therefore, we need to implement this functionality in a different way. And here comes the concept of dictionaries in Python. A dictionary is actually a data type in Python which is a collection of key value pairs. However, keys must be unique while the values can be anything. Let's actually implement this scenario using the data type dictionary. First of all, let me delete here everything, but let's keep print the students and the students variable. And if I want to implement a dictionary, I can say students equal. Now, this variable, instead of storing a list of tuples, it will store a dictionary. So here we are not replacing the concept of tuples, we are replacing the concept of lists in general. So we are going to replace lists and everything inside of the lists with this new data type that is called a dictionary. Here, to define a dictionary, we use curly brackets, not squared brackets like lists. That's why I told you we are going to replace the concept of lists. So inside of the curly brackets, I'm going to write the student ID followed by a colon followed by the student name. And since it only works as key value pairs, I can only have one value before the colon and one value after the colon. So let's say, for example, 1, 2, 3, 4, followed by a colon, followed by the name Alice. Then we write a comma. The first item is done. We will write the second item, which is the second student. 1, 2, 3, 5. That's the student ID, followed by a colon, followed by the student name, which is Bob, followed by a comma. Now we are done with the second item or the second student. Let's move on to the third student, which has an ID of 1, 2, 3, 6, followed by a colon and the name Eve. So as you can see, this dictionary contains 3 items, 3 students, and they are key value pairs. The key is the student ID, and then the value is the student name. So if we add a print statement and we say print students and we click on the run button, as you can see, the first print statement, it printed out a list because here we initialized the variable students with a list of 3 student names. Then the second print statement, it also printed out a list. However, it's a list of tuples where each tuple contains the student ID, the student name, and the student gender. However, the third print statement here, it printed out a dictionary. As you can see, it used curly brackets in the printing. Therefore, this is a dictionary where here each item is a key value pair. The key represents the student ID and the value represents the student name. If we actually say print type of students and we click on run, as you can see, it will tell you that it is a dictionary. However, if we here print type of, let's say, students, and let's copy and paste it here, and then we click on run, as you can see, initially it is a list, it is also a list, then now it is a dictionary. So now let's access the different items present inside of our dictionary. And to do so, we are going to use the key values because here the items are stored as key value pairs. So if I want to access, for example, the name Alice, I need to use its key to access this value. For example, I could say Alice is equal to students of 1, 2, 3, 4. Here, if I say print Alice and click on run, as you can see, it printed out the value Alice, which is associated with this key, which is the number 1, 2, 3, 4. So what happened here is students followed by squared brackets, I'm going to access the dictionary. However, I want to get the value that is associated with this key. And this key is 1, 2, 3, 4. So I go and search for the key 1, 2, 3, 4, and then I retrieve the value after the colon, which in this case is the string Alice. Therefore, it printed out the string Alice. And actually, there is another way to retrieve a value using the key. If we say Bob equal students dot get followed by parentheses or rounded brackets, and inside of the rounded brackets we write the student ID or the key, which is 1, 2, 3, 5. And here if we replace Alice with Bob as the variable name and we click on run, as you can see here it printed out Bob. So there are 2 ways to retrieve values from a dictionary using the key. Either you write students followed by squared brackets and inside of it you write the key, or you write students.get followed by rounded brackets or parentheses, and then you write the key, and here it will retrieve the value that is associated to this key. Therefore, keys in a dictionary are unique. They cannot be repeated. You cannot have two entries with the key 1234 or 1235 because each key is associated to a value. You could not have the same key for two values. Otherwise, Python will not know which value do you want to retrieve. Now, what if we want to add a new key value pair to our dictionary? Simply, we are going to write students followed by squared brackets, and then we write the new key value that we want to insert. For example, here 1237. That's a brand new key that does not exist in our dictionary. And if I say equal to, and here, for example, I write my name, which is Walid, and then I say print students, and I click on run. As you can see, here we have the new dictionary and the new key value pair is actually inserted or added to our dictionary. Here we have the key 1237 and we have the student name, which is Walid. So if I say, for example, print students of 1237 and I click on run, it should print Walid, which is the value associated with this key, which is 1237. Now, what if we want to remove or delete an entry or a key value pair from our dictionary? Simply, we are going to write students dot pop followed by brackets or parentheses. And if you remember the pop function from the lists, here the dictionary also has its own built-in pop function, which takes one input or one argument, which is the key of the entry that you want to remove or delete from the dictionary. For example, if I want to remove the pair 1234 and Alice, I'm going to provide the pop function with the key value 1234. And here, if I say print students and click on the run button, as you can see, it printed out the dictionary without the Alice entry. We have here 1235 and Bob, 1236 and Eve, 1237 and Walid. We do not have here 1234 and Alice because it was removed. What if I write the following statement? Eve equal students.pop, and I provide it with the ID of Eve, which is 1236, and then I say print students. Here it will perform two operations. First, it will remove the key value pair of 1236 and Eve, and then it will store the value, which is the string Eve, inside of this variable. So if I print students and then I print Eve and I click on run, as you can see, here we have our dictionary without the Eve entry. We only have two entries, Bob and Walid. However, when I printed the variable Eve, it printed out the value of Eve because here, after actually removing Eve from our dictionary, it took the string of Eve and stored it inside of this variable. Now, what if I want to store the gender along with the name under the student ID? How can we do so in a dictionary? Here in a list, when we used tuples inside of the list, it was simple. We had our student ID, our student name, and the gender. However, in the dictionary, it consists of key value pairs. And pairs, it means two things. Here we have the key, which is the student ID, and the value, which is the student name. However, we can replace the value with any other data type. It could be a string, it could be an integer, it could be a tuple, it could be a list, it could be anything. So let's have this new example here where we say students equal, and here we have a new dictionary, and then inside of the dictionary we write the key 1234 followed by a colon, and then, for example, let's try out tuples. So if I say Alice, comma, F inside of parentheses, which means we have here a tuple. Then here we write a comma and we move on to the second entry in our dictionary, 1235. And here let's have, for example, Bob and M. And finally, let's have our third entry, which is 1236 and here it would be Eve and F. If I print my dictionary and I click on the run button, as you can see, it printed out. Here we have the key 1, 2, 3, 4, and its value is this tuple. So this tuple is the value of the key. Same for 1, 2, 3, 5. This is the key, and this tuple, which contains Bob and M, is actually the value of this key. So if I want to print actually the value of the first entry, I could say here, for example, print students of, and I provide the key. For example, the first entry has key 1, 2, 3, 4. So I'm going to provide the key. And if I click on run, as you can see, it printed out the tuple, because the tuple as a whole is the value to this key, which is 1, 2, 3, 4. And then actually I could access, for example, the first item inside of this tuple. So here if I say students of 1, 2, 3, 4, followed by another squared brackets, and I write 0, which is the index of the first item, and I click on run, it prints out here Alice. If I say here, for example, 1 instead of 0, which means the second item inside of the tuple, here it prints out F. Because here, students of 1, 2, 3, 4, it will retrieve the value associated with this key, which is the tuple Alice, F. Then, when I have another pair of squared brackets, and inside of it I have an index, this means which item inside of this tuple do you want to access. Here, if I say 1, it means I want to access the second item, which is the F. If I have here 0, it means I want to access the first item, which is Alice. However, here we still have the same problem. What if I do not know the index of the gender or the index of the student name? Here I know that the first item inside of the tuple is the student name and the second item is the gender. However, if I do not know the order of the items inside of the tuple, I still have the same problem when I had the list of tuples. Here we can also have the same concept of, when we used lists, we said we could have a list of lists. Here we could have a dictionary of dictionaries. So if we write students equal curly brackets, here we are creating a dictionary. And then when we write 1, 2, 3, 4, which is the first key in our dictionary, followed by a colon, this time the value will not be a string nor a tuple. It will be a dictionary. So we write another pair of curly brackets, and then if I want to have a string as a key in my dictionary, I write it between double quotations. If I say name, followed by colon, here the value is Alice, and then the second key in this dictionary will be the gender, followed by colon, followed by F. We have the key 1, 2, 3, 4, and the value is this highlighted dictionary, which is actually another dictionary that contains two keys, the name and the gender, and they are unique. Inside of this inner dictionary, you only have one pair with the key name and the other pair with the key gender. What if we want to add a new student to our students dictionary? Simply after you are done with this key value pair, we write a comma followed by the new student ID, which is the new key 1, 2, 3, 5, followed by a colon, and then the value of this key, it will be another dictionary with the following key value pairs: the name, which is Bob, and the gender, which is M. And for readability, let's put this on a new line like this by hitting the enter key. And also here, we click on the enter key, and here we click on the enter key. So as you can see, here we have two entries or two key value pairs in our students dictionary. So as you can see, the first entry or key value pair, it has a key of 1, 2, 3, 4, and then the value is a dictionary which contains two key value pairs: the name, which has the value Alice, and the gender key, which has the value F. Here, the second entry in our students dictionary is the key 1, 2, 3, 5, and the value, which is a dictionary that contains the following key value pairs. The key name contains the value Bob, and the key gender contains the value M. If we write our third student 1236. Here, the name is actually Eve, and the gender is F. So if we print our students dictionary and we click on run, as you can see, it printed out here the dictionary with the keys as the student IDs, and then the values are other dictionaries which contain the name and gender of each student associated with a particular key or student ID. What if we want to access a particular key value pair inside of this dictionary? If we write here, for example, Alice equal students of 1, 2, 3, 4. So here I'm retrieving the value associated with this key, which is the dictionary that contains name Alice, gender F. Here, if I say, for example, print Alice, and I click on run, as you can see, it printed out the value, which is the dictionary that contains the key name and the value Alice, and the key gender and the value F. What if I want to extract the gender of Alice? So if I say Alice underscore gender equal Alice, and then inside of the squared brackets, we write the key, which is gender, and don't forget the double quotations. If we print Alice underscore gender and click on run, as you can see, it printed out F, because here the key is gender, so the value is F, so it printed out F. Actually, we could have done this using the following notation. If I say here, students of 1, 2, 3, 4 of gender, and I click on run, as you can see, it also printed out F, because students of 1, 2, 3, 4, here it will retrieve the value associated with the key 1, 2, 3, 4, which is actually the dictionary that contains the name and gender of Alice. And then when I write another pair of squared brackets and I write the key gender, which is inside of double quotations because it's a string key, here it will retrieve the value associated with this key, which is the string F. Therefore, it printed out F. Actually, we could have done it in another way. We could have said, for example, dot get here gender. And if I click on run, as you can see, it printed out F2. What if we want to insert or add a new entry or key value pair to our students dictionary? We can simply say students, and then we write a brand new ID, for example, 1237, is equal to the following value, which is a dictionary, name as the key, Walid as the value, and here we have gender as the key and M as the value. So if we say print students and we click on the run button, as you can see, it added this key value pair. We have the key 1237, and then we have the value, which is another dictionary that contains the key name and the value Walid, and the key gender and the value M. Now, what if we want to modify an entry in our students' dictionary, or basically edit a value that belongs to an existing key in our dictionary? For example, if we have this key value pair where the key is 1235 and the value is actually another dictionary, what if we want to replace this value with a new value, or replace this dictionary with a new dictionary? How can we do so? So let's first remove these statements because they are no longer needed, and then let's write students, and then inside of the squared brackets we write the key of the key value pair that we want to edit, which is 1235, followed by equal, and then the new value that we want to actually have in our dictionary, which is another dictionary, the name key and the value, for example, Alexa, and then the gender key and the value F. If I print actually the students dictionary and I click on run, as you can see here, the entry 1235 has a new value, which is a dictionary that consists of the key name and the value Alexa, and the key gender and the value F, instead of the old dictionary which had the key name and the value Bob and the key gender and the value M. And as you can see, modifying or editing an entry in our dictionary is similar to inserting or adding a new entry. They have the same syntax. Here, we write students followed by squared brackets, and inside of the squared brackets, we write the key, which is similar to the insertion mechanism. However, the difference is that here, when we want to modify or edit an existing key value pair, we write the key that already exists in our dictionary. So 1, 2, 3, 5 is already a key in our dictionary. However, if we want to insert a new record or a new entry, we write a brand new key that does not exist in our dictionary. Now, what if for this key value pair, where the key is 1, 2, 3, 7, and the value is a dictionary that contains the key name and the key gender, I want to modify or edit the key name only. I want to replace this string with another string, but I do not want to replace the entire value, which is a dictionary, with a totally new dictionary. I just want to replace this key name with a new value. How can we do so? If I say students of 1, 2, 3, 7, which is this key, followed by another set of squared brackets, here we will write name equal, for example, Tom, and then we say print students, and we click and run. As you can see, here it only modified the name entry or the name key value pair. Here we have the key 1, 2, 3, 7. We have the value, which is a dictionary. Still, the gender is M as it is. However, the key, which is name, its value changed. It's now Tom instead of Walid. So here, when we said students of 1, 2, 3, 7, here we access the value of this key, which is the dictionary that contains the name Walid and the gender M. And then when I said here inside of the second squared brackets, here I want to access this key, which is name, and I want to replace the value and have this new value, which is the string Tom. Now, for this key, which is name, we have a new value, which is Tom. And finally, if I want to remove everything from the student's dictionary, we can simply say students.clear, and then we say print, for example, the dict is followed by comma students. And if I click on run, as you can see, it printed out the dict is followed by an empty dictionary, because here dot clear is similar to the dot clear function of the lists, where it removed all of the items inside of a list. Here, dot clear, the built-in function which is present in a dictionary, also removes all key value pairs inside of a dictionary. And now let's see how can we loop over or iterate over tuples and dictionaries. But first, let's work using a simple example. Here we are going to create a variable called Alice, which is a tuple that consists of an integer value, which is the student ID, a string, which is the student name, and another string, which is the student gender. And if I want to iterate over or loop over this tuple, I could use for loops, because if you remember, for loops actually loop over or iterate over sequences. And this tuple is actually a sequence because it consists of 3 items or 3 elements. So if I say for item in Alice, print here item, and I click on run, as you can see, here it printed out the first iteration, it printed out the student ID, the second iteration, it printed out the student name, and finally the third iteration, it printed out the gender. So here, since I have 3 items, so for item in Alice, it will go through each item in this tuple, and here inside of the body of the for loop, it is going to print the item and return back to the for loop to move on to the next item. And now let's see how can we loop over dictionaries. Let's reinitialize our variable and overwrite the old students variable, because it is already defined here with a dictionary. However, you are going to assign a new dictionary to this variable. And this time the key will be an integer. However, the value will be a string for simplicity. Let's have 1, 2, 3, 4 as a key, and as a value, we can have Alice as a value. We can have 1, 2, 3, 5 as a key and Bob as a value, and finally 1, 2, 3, 6 as a key and Eve as a value. Now, if I want to iterate over or loop over this dictionary, it is possible using a for loop because it is also a sequence of items. However, I will write for key in students here because when I iterate over this dictionary, this temporary variable, which is called key in this for loop statement, it actually retrieves the keys and not the values. So here if I say, for example, print key, and let's comment this for loop, and if I click on run, as you can see, it printed out the keys. However, if we need to print out the value and not the key, we need to write inside of the print statement students followed by squared brackets, and then we put the key inside of the square brackets as if I am telling Python, give me the value that is associated with this key in the student's dictionary. So if I click on run, as you can see here, it printed out the values and not the keys, because by default, a dictionary, each item in the dictionary contains two parts, a key and a value. So when I loop over the dictionary, by default, it will retrieve the key and not the value. So here I wrote for key. I named my temporary variable name key because I know since I'm looping over a dictionary, it will retrieve the key and not the value. And then inside of the print statement, I say students of key, then use this key to get the value. However, there is another way to loop over the values present in a dictionary. If I say for, followed by a temporary variable name, let's call it value, in students.values followed by empty parentheses or brackets, here students.values, I'm invoking a built-in function called values, which actually ignores the key part. So as if here I am looping over the values directly without taking into consideration the key part. Therefore, if I say print value, and let's comment this first for loop, and we click on run, as you can see, it printed out Alice, Bob, and Eve because students.values actually brings the values. Therefore, here I am looping over the values, not the values and their keys. So for value in students.values, here I print the value. What if we comment now this students dictionary and work on the big students dictionary, which contains key value pairs where the key is an integer and the value is another dictionary? It will work the same. If I click on run, it will print the dictionaries here because now the key is the student ID, which is the integer, and the value is the dictionary that contains the name and gender. And also, if we try it on using this one, and let's comment the second for loop, and we click on run, it will print also the dictionaries that contain the name and the gender. And now let's wrap up this example by printing out the data type of the student's variable and the data type of the Alice variable. As we know, the student's variable is of type dictionary and the Alice variable is of type tuple. So here, if we use the old printing technique and we write print followed by parentheses or rounded brackets, and inside of the double quotations, we say the data type of students is, then we have a comma after the double quotations followed by the type function, and inside of the brackets of the type function, we write the variable name, which is students, or we can use the new modern printing technique, which is print, and inside of the brackets, we write F, followed by the double quotations, and inside of the double quotations, we say the data type of Alice is, and then here we have curly brackets, and inside of the curly brackets, we write type of Alice. And here, if we want to print the student's variable, and here, let's print the Alice variable, and let's comment this for loop. Now, if I click on run, as you can see, it printed out the value inside of the student's variable, which is a dictionary. Therefore, it said the data type of students is dict, which stands for dictionary. While here, it printed out the value inside of the Alice variable, which is a tuple, And as you can see, it printed out the data type of Alice is tuple.
Now we are done with the introduction to Python in under 6 hours crash course. Thanks for watching. I hope you enjoyed it and learned how to write your first Python program. If you have any questions, don't hesitate to write them in the comments. Also, if you liked the video, don't forget to like, comment, share, and subscribe to the channel. Additionally, you can write in the comments what programming topics do you want to learn next. See you in the next video and goodbye.